I'm MC Toon, and it's Tuesday night, and it's bogging a little bit, but we have a discussion, debate. I think it's more of a discussion between Professor Phil Bell and Shane St. Pierre. And let me get I gotta get them up on the screen here. But they can say hello. Hello, guys.
Hello, how are you?
Hey guys, nice to be back.
Good to see you, Shane. Good
Hey
to see you,
Phil.
Michael.
Good stuff, man.
All right, I'm almost
The only
ready.
person I wouldn't want to talk to is Fight the Flat Earth. That guy's just absurd. He doesn't do the debate so much as get free content and then make people look dumb.
So I am wearing his shirt, but don't tell him that.
That's all right.
So, all right. Well, I again will be mostly sitting to the side here while Phil and Shane do their thing. So you two, you go ahead. Why don't you both introduce yourself? Start with Shane. Go ahead.
What's up, guys? So I'm Shane. Been here a couple times. Recent flat earther. Let's see. We were on McToon for 4 hours the first time. Had a good long chat. Went over a couple of things. Learned some stuff. Made some new videos from the new content you gave me, and we'll hopefully go over that today if it comes up relevant.
Sure. And I'm Phil. Probably most people in the chat probably know who I am. And it's good to be here, Michael. I think this is our first time. So
I think so.
Is it? Oh, I thought you guys must have known each other. Huh.
Oh no, we've known each other, but this will be the first time that I've been on this channel.
Yes.
Yes. So basically, Shane and I have had a bit of a quick discussion on this, and we both agree that we are rational people. Shane says he's rational. I reckon I am, and Shane thinks I'm rational, and I think he is too. So that's kind of going to be the theme of it. So we're going to look at different things and say, well, is it rational to believe this, or is it not? Okay. So let's see if we can go, that way rather than the usual sort of formal type of debate, which I think usually goes round in circles. Let's see how we go. Okay. So why don't we just pick on a few things? Well, just help me out. You obviously do think the Earth is flat.
Yes, sir.
And I saw that you had deep inside the rabbit holes app thing running. You had a clock thing with the flat Earth. I presume you think that your idea of the flat Earth is that thing, yeah?
I think it's the model most closely representing the true world, although we don't live on a model, right?
Okay, well, we can discuss why you do think that, but because I don't want to straw man you, okay? And you also think that it's covered with a dome, is that right?
I personally do, but not all flat earthers do. Personally, I'm of that opinion as well. Yeah.
Okay. No, actually, it doesn't matter what other flat earthers think. It's only what you think.
Then
okay?
Yes.
So I actually don't care what they think. Especially don't care what Oakley and John think. Okay. All right. So why don't we start? Why do you think the Earth is flat? What made you select that model?
Well, for me, it was these two things, right? Realizing the celestial star pattern all around Polaris from the equator in this perfect circular pattern, the position of Polaris, and then the sun appearing local from in the clouds, behind the clouds, and in front of the clouds at the same time, all sorts of ways. Those two things together are what did it for me.
Okay, all right. That's let's just stay with those two for now, because obviously you probably have more, but anyway, let's stay with those two. I'm really glad you chose those two. Actually, that's fantastic. Okay, so let's choose the one that you chose first, which is the circular star trails.
Mm-hmm.
Okay. Now, presumably, we're looking at those circular star trails. They look like looking at Polaris. Yeah.
That's right.
Now, according to the model that's over there to your right, probably my left, well, my right, probably your left. That particular model that you're looking at has the North Pole in the center. Would you agree with that?
Yep.
Okay, good. And you did agree that you were rational, right?
Are you going to show me the southern portion of it and pretend?
No. That comes later. That sort of gets worse at that point. So let's say, for instance, you were standing underneath a circular light fixture.
Okay.
Right. It would look perfectly circular, just like the one that's behind you, right?
Sure.
What about if you backed away from it?
Right.
So far that it was at the horizon, do you think it would still be circular?
Ovalish, maybe?
I agree. So, because you certainly are a rational person.
I've also seen your videos.
Okay. Can you explain why it's not oval?
Perspective. It's the same circular pattern of view at a skewed angle, so it skews the shape.
But the perspective is the reason that it looks oval.
Right. So the farther you get from the equator.
So why doesn't it look oval? Perspective is the reason that it looks oval. That's already established. We've already got the word perspective.
Right.
Perspective and oval go together in this context.
Right. But they do move in a perfect circular pattern, regardless of your perspective.
Well, they do above it. If you directly underneath it, then
sure.
I agree that's what you'd see. But as you backed away from it, it would definitely be oval.
Right, but
so you can see that from a rational point of view, that is a problem, isn't it?
Not to me, no.
No, but come on, you said you were rational. Why is it not a problem to you?
Well, the fact that it looks different from a different perspective doesn't change the original factor that the perfect circular pattern makes no sense in a heliocentric model.
Oh, no. Let's just discuss your model, okay?
Right.
I'll show you why it does make sense in the heliocentric model. That's not a problem. But let's just work on yours now. Let's not do a John, hey? You basically agree that if you walk away from a circular pattern that's above your head, it's going to look oval. You cannot deny that, right?
Correct.
That is just perfectly rational, and that is because of perspective.
Right.
Yeah. Okay. So clearly, if you were backing away from the North Pole, we're standing underneath it and backing away from it, at some point it might reach the horizon. I'll show you why it can't later on, but in any case, let's say it reaches the horizon. It most certainly won't be circular at that point. I mean, how is it going around if it's circular at that point? The stars can't possibly be going around the North Pole then on a flat plane, if at that point it's still circular.
Okay.
All
I'm
right.
with you.
Okay, good. I'm glad you are. All right. So I don't want to, because time is a thing. So I don't want to labor over the points. So we've made a point. So let's say, for instance, we have a ledger. Okay, I'm sure that if we ask the people in the chat, one or two, on the ledger, you'd have to say that my position was a little bit more rational than yours, right?
Well, I mean, we didn't change anything about my original point, is that they move in a circular pattern. It doesn't matter where you observe them from.
We're not disagreeing that they move in a circular pattern, but they move in a circular pattern directly above your head.
Then I would think I'm more rational then.
No, but we're not looking above your head. You're looking at the horizon.
But I'm not looking at my perspective. I'm thinking about the actual position as they rotate around in this heliocentric model where it's supposed to be,
Okay, but you realize that those pictures there are taken at the horizon, right?
Sure.
That there wasn't somebody standing on the ice at the North Pole taking those pictures, right?
Fair enough.
So therefore they can't be circular. That's impossible.
So what shape do you think they rotate in?
They have to be oval.
Okay.
because you've backed away from it, and that's perspective.
So then why don't they look like that?
How do you mean look like what?
They're like scrambling all over the place, like a big spaghetti monster in the sky, making all sorts of movements all over the place.
Yeah, yes, no. When I get my turn, I'll certainly be explaining that. No problems at all. No, I can't wait to get to that. Okay, so the other one that you showed us was the sun. Okay,
right.
and I want you to think about the stars as well when we discuss this. Okay.
Okay.
So I've got a little bit of technology, which I use when I'm on Zoom and teaching. So I'll do that. So may I share?
Oh, yep. Just let me. It may not be enabled. Let me do that.
Sure.
Yep. Looks like it's off.
Go, and then. Yep. Whenever you're ready.
It looks good. Okay, so you can see you can see the screen.
Yep.
Yes.
Okay, so let's say we're flat Earth. Okay, so there's the ground right there. Okay, I'm going to draw pretty rough, so just forgive me. And we've got the sun. Okay, so you might start here. Let's say our little fella is right here. Okay, and there's the sun right there. Okay, and of course it's flat. Yeah? The sun's over there, right? And over there, and over there, right?
Okay.
Let's put some others in the middle like that. Okay. So that's kind of what happens. The sun goes across the screen like that. Can we agree with that?
Yep.
Flat Earth. I'm not straw manning you here, am I?
Not yet, no.
Okay, that's good. All right, well, let's do something then. Okay, I'll try to use my mouse to do this. Okay. I could see the damn thing. For some reason, it's not coming across on the screen. Okay, I'll do it by hand. Okay, so this over here, let's say we've got a ray going down here, would look like that. Okay, and then the next one would be like that. Next one would be, whoops, like that. I'll get there yet. Next one would be like that. Next one would be, whoops, I just have to remember to drop it, yeah. Pardon me. Next one there, you get the idea, don't you? Yeah. And this little tablet is misbehaving, so. Okay, and so on, okay?
Okay.
Do a couple more, right? I'll just do it by hand, okay? That one there, and that one there, okay?
Okay.
All right, so do you agree with this so far?
Yep.
Okay, good. All right, then let's say, for instance, around about here, you'd see this, and the angle's not quite right, but let's say this was 30 degrees, okay? Down here. Okay, so this is 30 degrees that you're looking at.
Mhm.
So this angle here, right? Understood?
Yep.
Okay. This is X. How far do you think the sun is from the Earth? How high do you think it is?
I don't know.
Just give me anything, a rough one. 4,000 miles?
Let's say 110 miles.
110 miles. Okay.
Yep.
Okay, so all right. miles. All right. Okay. Okay, so how would we work out what 30 degrees is then?
Oh, I forget my trigonometry.
Okay, it's simple. So basically, this x
Cosine.
would be equal to 110 over 10, 30. Okay. All right. So we have a calculator handy. So 1 second. Just give me a moment. I don't carry that 10 tables around my head. So that's 190 miles. This now is. So x is 190 miles when it's 30. Okay. Let's go all the way because I haven't got a lot of room. Let's say it's 5 degrees. Okay, so it's 5 degrees. So now it's going to be 110 over tan of 5 degrees. Okay.
There we go.
Okay. That's 1,257 miles. Okay. So let's say that was 5 degrees. X would be 1,257 miles. Would you agree we'd still be seeing the sun?
Yep.
What do you imagine it would be if it was 0.5 degrees, then where we would still be seeing the sun?
Where would we be seeing the sun?
Well, we'll at the horizon.
I mean, when would we not see it?
Let's work it out, okay? We're both
Okay.
rational people. We agreed. All right. So 110. Because the sun doesn't change, doesn't dip down, does it?
Only by perspective.
Oh yeah, no, we agree with that. That's why it's only 5 degrees. So it's okay. $12,604. Wow. I mean, you are a rational person. We just both agreed that we were both rational people.
Sure.
Do you think at 5 degrees you can still see the sun, but on flat Earth it's 12,604 miles?
Did that make it 93 million miles away? I must have missed that part.
Okay, so no. Just think about this. So the sun is way past Perth from Sydney to say from Melbourne to Perth or Sydney to Perth. We're only looking at 2,700 kilometers. The sun is 6 times further. So in other words, Perth is already dark. It's long ago, but you can still see the sun.
Okay.
So the sun is 12,000 miles away, and we can still see it. Does that kind of work with that model that you've got there behind you?
Yes.
How does that do that? Explain it to me. Remember, you've got 12. Remember, you can still see the sun because it's half a degree above the horizon. You can still see it. And yet it is 12, and yet the Earth at that point is 12,000 miles, 12,600 miles away.
How do you figure that?
You want me to write down again?
Nope, nope, I don't. But okay. So we're saying that on a flat Earth, we wouldn't be able to see the sun past what?
No, that on a flat Earth, you should be able to see the sun for the sun is 12,000 miles away. The Earth, your Earth on that model behind you wouldn't be that size.
Oh, so we think light travels infinite amount in an atmosphere, or light travels forever?
It's like it's never going to get dark, isn't it?
You can only see a limit to your human perspective, no matter how
No, but
far that is.
it's not going to get dark. Look how far the sun is. What about the stars that are now also in that direction? How can we see them?
Right. When the sun gets far enough away, it takes its light with it. So it goes into the atmospheric depth and then no more light, hence darkness.
But we do see the sun. It's 5 degrees above the horizon, and it's supposedly 12. I know what you'd like it to be, but that's not what the reality is. The reality is the sun is there. You can look at it. I'm very close to the beach.
So if I was over here,
I can go to the beach and look at the sun go down in the west.
if I was over here, you're saying we should be able to see the sun over here.
You can see the sun over there. You can see the sun 5 degrees above when it's 5 degrees above the horizon. Would you
can't
agree
see the
with that?
sun
You
in
can
New
see the
Zealand
sun?
from Arizona, though. If you're in Arizona, you can't see New Zealand sun, right? That's why it's dark and light.
No. Let's not get bogged down. Do you agree that you can see this? That if you went to the beach, and like if you were where I am, and you were looking southwest, that's where you'd see the sun going down, right? Which we'll get to that later. Okay, so the sun's going down southwest, and I certainly can see it when it's 5 degrees. You know, so I mean, that becomes a beautiful sunset. 5 degrees, and then you can watch it keep going down half a degree, you still see it. That's literally, you can literally see it. But if the world was flat, southwest, remember? And remember, I'm in Australia, and it's southwest. That would be 12,600 miles away, southwest. Do you know how far it is to Antarctica from Australia? It's 4,000.
Something there, about 4,000 miles.
Yeah, well, not even miles. It'd be about 4,000
meters.
kilometers.
Right.
Yes, and you and yet I can see the sun 12,600 miles away. You said you were a rational person.
Didn't we say the radius of the Earth was what, 6? Let's see.
Come on, we're just talking about flat Earth.
Right, but the whole distance.
At the moment, we're just talking about the Earth being flat. Okay.
Right. So 6,376, 551. So 6,378,561 meters. Right, is the circumference of the spherical Earth from McToon's website, I think. Right.
No, don't worry about the round Earth. We're just assuming that it's flat.
Right.
We'll get to that. I will be under the hammer to explain why I'm saying why you know. I mean, I've got to face the same challenge as you have.
Sure.
You've got this challenge. My challenge will come. Don't worry. You can have a crack at me then. Okay. But in the meantime, you have to agree that these 2 points that you made, which you rationally chose to believe that the Earth is flat, are both irrational. It doesn't make the slightest bit of sense that the sun at 5 degrees, at 0.5 degrees, which you can see, must be 12,604 miles away. And
are we not supposing a small sun, a small local sun?
Not that far.
So we're assuming a giant ball of gas 100 miles up, which would cover the whole sky? No, we're assuming a small local sun in this model, right? For on the flat Earth.
No, but why? Okay. Oh, sorry. Look, let's go over this very slowly, all right? And I'm not being condescending or anything. I just want to make sure that all along the way it's clear. If you were with me standing on the beach, looking southwest, we would both see the sun go down. That's That's what happens in over here where I am. It's where you are in Boston. Well, you're not going to see it because you're on the East Coast, right?
Mhm.
Okay, but if you went over to California for a bit of a holiday, you would. Now, I can see the sun. The sun goes down southwest. If I keep going southwest, I'm going to run. Will I run into Antarctica? I'll probably miss it, actually. But if I was going directly south, I definitely get there. Yeah, I'd have to look that up. I'm not sure. I could be wrong about that. But in any case, I'd be heading in that direction. Now,
Okay.
that's only 4,000 kilometers away. I mean, 4,000 kilometers is a long way, but it is 4,000 kilometers away. But we're both standing on the beach looking at the sun. It's half a degree at the horizon. Okay. And in order for the Earth to be flat, that sun has to be 12,604 miles away. Otherwise, it could not be at the horizon. That's why I drew these, so that you can get an idea.
I think we're assuming some factors that I'm not familiar with.
At 5 degrees, it's just 12. It's what did we say it was? 1,257. At 30 degrees, it was did I say 190? I mean, this is just basic trick.
But this is based off the number that I randomly threw out there, right? From the start for 110 meters above from the original perspective.
Do you want to make the distance less than 110 miles?
No, I'm just trying to get the variable straight in my supposed example here.
What do you reckon? What do you reckon if you said the was 50 miles?
Well, how big are we assuming the sun is?
It doesn't matter about the size.
If we're talking about how far we can see it, sure it does.
No, but
a micron versus 1,000 meters, right?
We don't have to, if anything. You and I are standing at the beach. We can actually see it.
Okay.
So we don't have to say if we can see it. We don't have to pretend that it's disappeared. We both can see the sun.
We're both in Australia on the beach.
We're both in Australia on the beach.
Okay.
Looking southwest, we can see the sun.
Okay.
It's 0.5 degrees above this horizon. We can both see it. Okay. Now, for that to be possible on flat Earth, that sun would have to be 12,600 miles away. That's the only way that's possible.
Okay.
That's all I'm saying. Okay.
Okay.
All right. So you can see that's pretty rational. All right. So
certainly.
Now I've got to explain to you those two things myself. So because I need to be challenged. We agree?
Sure.
Okay. All right. Well, let's see if I can draw an Earth. I think I'll draw a green one.
Don't forget the oblate spheroid geoid shape. There we go. Oh, look at that.
That's what I think the Earth looks like. Okay.
Yeah, the Grass Tyson would disagree.
Okay. Oh well, if it was this, if this was my photograph, and I was looking at the Earth and it was this size, and this is what this from my perspective, it was that size. I guarantee you, it would not be. It would be perfectly circular. Okay.
I'm with you.
All right. So that's totally irrelevant. There's no place you can get close enough to it for you to notice that it's 14 miles bigger at the equator.
Gotcha. Okay.
Right. It's impossible. Okay. So this is the Earth. All right. Now remember. So what we'll do is, it does have a tilt. So let's do that. Okay. So kind of like that. Okay. And a very, very long way away. I'm going to put it in black just so we can see it. Okay. Okay. Okay, I probably should use the circle again. I'll use black. Okay. Okay, just above that tilt is Polaris. Okay.
All right.
So this is a very, very long way away. So this is not even to scale. I'm going to see if I can improve this a bit, because this is hardly going to work this way. You know something, I think I might just scrap this and start again, because the scale is just so wrong. It's impossible for me to make the scale right, of course. So what we'll do is we'll put the Earth down here this time. So I didn't want to make it black. Actually, I'll keep that there. Okay. Let's make my blue Earth. So there we go. And all the way up here, because of the tilt, all the way up here, we've got Polaris. Okay. All right. All right. It's much, much further than that. This is ridiculously out of scale. Ridiculously out of scale. Okay. I can't stress that enough.
Right. This is supposed to be the 23.3 degree tilt.
Yeah.
Yeah.
So it's got the 23.3, but Polaris, as far as Polaris goes, the distance between the two of them, that would be ridiculous if it was the sun, let alone Polaris. Okay.
Okay.
All right. So, however, the point is that let me draw that line again. See if I can get that to be accurate. Whoops. Helps if I grab a line. Okay. Sorry if this is running a little bit slow, but I think it's important that we do this.
I'm impressed with your paint skills on the fly, to be honest.
Okay. All right. Okay. All right. So here we go. This is here it is, Polaris there. Now, remember, in the way we'll have it, Polaris is going to be going around in a circle. Okay. All right. So if I were to draw the direction that Polaris will go, we'll be going. I'll use the black. It'll be kind of going from that aspect. It'll be going like, well, I can't actually make this thing move around the way I want it to. It only has one aspect to it, but it's going around like that. Okay.
I'm with you.
All right. Okay. So if you were that far away, okay, and let's draw somebody else having a look at it. Okay, let's say, for instance, this green person having a look at it. Whoops, I keep forgetting to change this. I keep forgetting to change my get this thing here. So I'm somewhere else, somewhere in the northern hemisphere. Okay, over here at Minnesota, having a look at it. Actually, no, Boston. Look at it. I meant Boston. Because you can see Polaris from Boston, can't you? Yeah?
I can, yeah.
Boston's pretty high up. Yeah. That's not that far from New York, is it?
Nope. 3.5 hours.
Yes, that's pretty. So I'm not sure. I mean, I don't follow these things. Do you know what the latitude is?
No.
Look, so the only one I do know really well is Minnesota, because that's 45. Okay, all right, but I don't know Boston. But do you realize that if this person looking at that would also see the star, would see these Polaris just like that?
Yeah.
Okay, that's rational, isn't it?
So far.
And this is going around in circles, yeah.
Let's see. 42.36 is what it is. If it matters.
So do you understand why it's possible for somebody in Boston to take a circular star trails at Polaris. Whereas if he was on flat Earth, as we've discussed before, that would be impossible.
This is like a 3-body problem being divided into separate 2-body problems. I'm talking about the whole heliocentric spinning heliocentric mess of a web of a star trail to get perfect circles. This is one star from 2 perspectives on a globe.
We just have to discuss discuss. It's better to go in rather than try to confuse all these things together. Just look at an aspect and say, look, that does not work. Okay.
So far, so good.
That is irrational on a flat Earth, and it is perfectly rational on a globe. But Shane, I'm afraid it gets a little bit worse.
I hope so.
Okay. You see those circular star trails that are on the horizon at in the north?
Mm-hmm.
You can see them in the south too. Now, let's think about what that would look like on a flat Earth, okay? So I'm going to put this away. And let's do our flat Earth, okay? I'm going to, all right, so here we go. I think I'll use this because the Earth is kind of bumpy. Oh, here we go. My mouse is misbehaving. Okay, there's our flat Earth. Almost makes me laugh when I say that word, but never mind. Okay, sorry. Okay, so flat Earth. All right. So there it is. Now, if we are looking south, you'd expect this is not going to be easy to draw, but I'll try. Okay. So I'm going to use the black. I'm going to use the black to do this. I would think that if I was looking at things looking south and the Earth was flat, right, I'd be seeing, I'd be seeing this sort of thing for star trails. This is exaggerated, all right? But oh, that one went wrong. Okay. Okay, so you know what I'm talking about? You'd see, you'd see the stars going like this, wouldn't you? Would they be like that? Yeah. They'd be sort of switching across the horizon like that, wouldn't they? Actually,
right.
Almost flat. From a long way, okay? Because they're all going around Polaris. All the stars are going around Polaris.
So we're squishing our circle into an oval, right?
Even the Southern Cross is going around Polaris. Is that right?
Yes.
Okay. Well, do you remember that circular star trails that you showed me before?
Mm-hmm.
You can see one of those in the south as well.
Right.
Surely that's not rational.
That one I'll give to you.
Not even this perspective.
That one I'll give to you. Southern Star. Yeah, I do. The Southern Star Trails, I can't rationally, loquaciously argue why we would see it the way we do it when we do. But
well, there is an answer.
There's a globe. Nailed it.
Bingo.
Right.
Let me show you why.
Okay.
Let's say now this same picture, so I don't have to draw it again. It was looking north, and that was Polaris. But now this little spot over here is Sigma Octantis.
Okay.
This is still going around. And that's any person over here in the Southern Hemisphere, let's say over here, me in Melbourne, I can look across and I can see that. And it's going around, and I sit there with my camera. I can make perfectly circular star trails with it. Now, you being a rational person just like me, which one would you choose? The one that you cannot explain, or the one that works perfectly?
Based just on Southern Star Trails, I'd be a Glober just like you.
I think you should
Fair
try.
enough.
I reckon you'd be heading in that direction, eh? Because this alone should give you lots of reason to pause. Would you agree?
Yep. Based on Southern Star Trails alone, absolutely, I'd be with you.
You're about the most the best Furf I've ever had the pleasure of talking to, actually.
I appreciate it. I mean, doesn't mean, that I believe from every other factor,
No.
but this specific instance, from what you give up, I'm with you. I agree.
Look, I could only wish that I could have changed your mind, and then we finished that. And
We're not done yet, right?
I'm back to the globe.
Every time I come on here, I say I'm willing to have someone bring me back and convince me. I'm not going to disregard things. This is a good example.
This should be a major thing for you, right?
It was a stumbling block to believe flat Earth.
When I showed you with the sun, surely that would be, that has to be convincing, right?
No, that one's a little bit less so.
You didn't explain why it's not convincing.
Well, we assume the sun is small and local, like 32-ish miles across and about, 7,800 miles up in the air, traveling around a local flat Earth. So when you say we can see it from across the world, that doesn't make sense to me. We can see it only as far as your perception allows it to see before it fades into the atmospheric soup, so to speak.
That's lovely, but that's not what happens, is it? Because we can actually see it. When I go to the beach, there's the sun, right? There's the sun at 0.5 degrees of the sun. I can actually see it. It's not a pretend sun.
Nope. I would agree on that.
Sun. Well, I just demonstrated to you that this actual sun that you're looking at must be 12,604 miles away in order for this reality to be right. In other words,
isn't that the diameter? The whole
the sun would be higher up if it were closer. It's not possible for that scenario to happen where I can see the sun and it's not 12,604 miles away if the Earth is flat. That's a long way to see something, by the way. It's 12,600, but not to see a star, of course. If you're a heliocentrist like me, that's nothing, because I can see stars trillions of miles away.
Trillions, forever
and
almost.
The sun is a star.
Right, for ignoring the inverse square law of light and all that good stuff.
No, it doesn't actually, because any photons how do you get to zero?
Well, as soon as if it gets twice as far, it's 4 times less bright, right? Something like that.
Yeah, but you still see it. Still, photons are coming from it.
But only until the limit of your human perspective, and your angular perspective will only go so far.
I don't have any control over the photons that are coming towards my eyes.
Right.
And there's nothing stopping them from coming towards me, so I'm going to see them whether I like it or not.
We also think the stars are about the size of the sun, right? We don't think they're a billion miles away, reflecting light through trillions of miles.
Most of them are a lot bigger than our sun.
Sure. But we think that all just lights in the sky, right? But
sorry. I know what you think they are. I mean, you call them lights in the sky. I think they're lights in the sky too. But they're lights in the sky that they suns, they other people's suns.
So people have claimed and put in textbooks.
Well, I mean, I'm showing you why it's rational to think that.
I agree. It's rational. With a whole bunch of math, right? And some explanations.
And I've also showed you how it's irrational not to think that.
From your perspective, sure.
Oh, no. Both of our perspectives.
Only if we assume every single variable in the same value, right? Which I don't think we are.
No, but I gave you an opportunity to tell me how high the sun was. You could have said 80, and then it would be like 10,000. It would still be ridiculously too far away. You think it might be 5 or 6 miles away, the sun?
No.
Okay. Well, planes would crash into it, wouldn't they?
Probably, right? Something would crash into it, but I mean, we don't know that it's.
All right, let's take a different tack. The sun's pretty hot, wouldn't you say? I would say the people. I would say that the people in the UK would be saying that. Our friend here, Michael, is in an air-conditioned room for a very good reason.
Oh, me too.
Okay, that's because the sun is bloody hot, as we say in Australia.
Right.
Okay.
Right. So
why does it get cooler when you go further closer to it? I mean, like at even at this heat, where it's so unbearable that Michael and you are in air conditioning, right? If you both got in an aeroplane and went up to cruising height at 35,000 kilometers, it would be minus 51 degrees C.
You mean without being right in front of the sun?
Yes, it would be minus 51 degrees C with the sun bearing down on the aeroplane. The atmosphere around there is minus 51.
Okay.
How can the sun be local? How is that rational?
Well, how big is we assuming the sun's heat impact is in a small radius, so 32 miles across, 900 miles across? Are we assuming it's hitting parallel rays from 93 million miles away when we see crepuscular rays?
You said you're in Boston.
No.
Michael's in Minnesota. Other people are in California. The people in Mexico, in Baja, California, are even further away. They also need to be in air conditioning. All of you need to be in air conditioning. So if we just look at the United States, that's pretty far. And yet all of you are sweltering underneath this heat.
Right. Our local sun circling in a tighter circle around the Tropic of Capricorn means it's right above you. And when it gets further on the Tropic of Cancer, it gets colder. And then Australia gets the heat. Right? Like this little model behind me. Boop.
No, I agree. I know what you think of that model. I'm just talking about what's happening today.
Okay.
You know, that's why Michael's in, well, it's dark. It's dark for him. But, you know, during the daytime, he would be in, it's nighttime and he's still in air conditioning.
Me too.
Goodness gracious, the sun really did a good job heating up the earth, didn't it?
Right.
All right, he's still in air conditioning and it's nighttime.
I've never measured the temperature outside the airplane, so that one kind of threw me. I didn't know it was that cold, right?
You know, I don't know if they. I mean, I don't know. I
assume you're probably right.
I know. In business class, you got those little TVs. I presume you have them all over the airplanes. They tell you what the temperature is outside. Okay, it's minus 51 degrees at 30. It's really quite consistent. It doesn't change much at all. That temperature. You look it up. 35 degrees, 35,000 feet, 51 degrees. Wow, minus 51. It's pretty constant. You'd expect if it was local, it's going to get hotter and hotter, wouldn't you?
As you get closer and closer, yeah.
Yeah. Now, so it's not rational that it gets colder, is it? Remember, we're both rational people. We agreed on that.
Right.
Okay. Let's try another one. Yeah. Let me think. I just had one on the top of my head, and I kind of lost it for now. It's all right. I'll come back to this later on. All right. Let me show you something. Okay. I'm going to unshare this for now. Okay. And I'll just show you this. I'm going to share that. I've got to be careful. Myself. So I'm just going to open up just bear with me for a second, please, everybody. Okay.
I am bearing with you.
Thank you very much, Michael. That's very gentle.
Bearing with us both the whole night, huh?
Yep.
Imagine coming on your own show and not saying a word.
It's certainly
Very
different.
gentlemanly. Something I forgot to mention, and this before. So let's just talk about this rationality again, because we're both rational people, as we agreed. Okay, so I'm just going to share this screen. Okay. Now, before I go ta-da, we're both rational people. Agreed?
I feel like I'm walking into a trap, Phil. I gotta say. All right, yes.
You're very rational. You worked that out. Okay. Have a quick look at this and see if you can work out what's happening. Do you get it? Now, you see, this is Australia, even though that's ridiculous. We're not shaped like a sausage dog or a flatfish, right?
Right.
It's not us. It's actually the distance from Perth, which is about there, to Sydney, which is about there, is roughly the same distance as across this way. So if you could almost draw a box, a cube around Australia. It's very, very close. This distance, the distance north to south is almost exactly the same as the distance east to west. So this is so ridiculously out. It's not funny. You know, most of us have actually driven cars all the way from there to there, so we know the distance. And a lot of us have traveled from say, Adelaide to Darwin, so we know what it takes to get to our north. We know our country pretty well.
Mm-hmm.
It's not like this. So this map is clearly wrong if this is what you accept. But that's I digress, because it's this other problem is much more important. Remember, we're talking about here. Do you know what the Southern Cross is, right?
Yeah.
Yeah.
A formation visible really from, let's say.
It's like the most important stars to us. In fact, heads down and points to the southern celestial pole. You know, to Tantus. It is extreme. You know, people have shops called, you know, the Southern Cross Garage, Southern Cross this, Southern Cross that. Okay, Southern Cross Pizza. Okay, I mean, we really care about the Southern Cross, and guess what? They also do in Cape Town. And they also do over here in South America. You see, we all look south and see the Southern Cross. But you know what? It gets a little bit worse than that. You see, because you see this line over here across there, that's where the sun is.
Yep.
On this side, it's nighttime. On this side here, it's daytime. You see what this? It's daytime because you can see the sun over there, right?
Right.
Okay. We'll get to that in a minute again. So now, these people over here in Sydney can see, are looking, it's nighttime, they can see the Southern Cross. And these people over here, about 120 degrees away, actually it's more like 150 degrees away, can see the Southern Cross as well at the same instant. They can get on a cell phone, and they can get on a cell phone and say, you know what, I can see the Southern Cross. Do you think there are two sets of Southern Crosses?
Nope.
You must be saying by now that model behind you is irrational.
Nope.
You must be saying that. You cannot be a rational person, as you told me you were, and I accept it, and not say that this particular model that we're looking at here, that's irrational.
Well, a special set of circumstances, I think, would make sense to me, where we would see it.
I'd love you to tell me how the people in Sydney and the people over here in Cape Town can see the Southern Cross at the same time, looking 150 degrees in different directions.
Let's see. So, what's the leftmost part of Australia called? Is that, or let's see, westernmost part of Australia?
Perth.
Perth. And then let's see, rightmost southern tip of South America.
Over here.
Right, eastern, I guess, most tip, right?
Oh, you can pick anything. Pick Buenos Aires.
And then the
here.
middle of Africa, I think.
Or
Those,
here.
Nope.
Kenya.
Or if I can share real quick, I have a picture, I think.
All right. I'd love to see how you can see the Southern Cross from both of those places at the same time. On a model that looks like this.
Mm-hmm.
Okay.
Oop.
I'll stop sharing if you want to.
Sure. Let me see. Share. I'm sharing.
Mm-hmm.
So these three positions right here at these times, you know, would be able to see the Southern Cross.
Yes.
Right.
Well, the one in Brazil might not, but yeah, certainly the South Africans would and the Australians would. But the Australians wouldn't be able to see the Southern Cross during the daytime.
Well, that's why I like when we move it all the way over here, it's just about dark on this. That's why I asked for the westernmost tip. It'll be dark here, dark here,
it's not. It's
dark over here.
That's daylight. That's definitely daylight.
It is right now. It is definitely right now because BitChute is not loading for me. But there we go. All right. So where were we? Right here. Come on, BitChute. Sweet. There we go. Right there. So dark Australia, dark Brazil, dark Africa. That position right there.
Mm-hmm.
So here we go. Flat Earth map. Same position. As we rotate, boom, right there. That's how we would see the Southern Cross from those across the Earth at the same time, all in the night. Agreed?
No, I don't, because that's not half the Earth in the darkness. So it's so totally wrong. There's no way known you'd get this darkness around here at the same time. This is totally wrong. The reality is half the Earth is in darkness at the same time. So that's wrong. That is just totally wrong.
Well, that's all I got, Phil.
Well, it's wrong. So you want to try and get something that's right. Then if you're going to, look, I commend you for having a go.
What about the angles that they see it?
What do you mean?
Well, they don't.
Where they don't look.
So you had it for a second there, right there.
Yep.
That's not the angles that they see the Southern Cross at. They see the Southern Cross nearly
Looking
due south.
Yeah.
Not exactly.
Right, but
nearly.
every direction away from the center is due south, right?
Yeah, and so those arrows don't demonstrate looking due south on.
Yeah. The Brazilians are not looking south on your map, are they?
Southeast? Well, south. No.
That's
South
north,
perspective is always south.
No,
That's
Right?
north.
So this is
That's
south,
northeast.
south. On the flat Earth map, every direction away from the center point is south, right? South, 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 south. If we do, let's see.
But those arrows aren't looking south. Those arrows are looking not south.
Yeah.
From their perspective, they are looking south, though. That's the
No.
argument.
The one in Brazil is looking northeast.
If
not
it's toward
south.
Antarctica, that would be south, right?
No, you said always. What way is south on that map?
From anywhere you
opposite-
stand, if
the
you look
opposite
towards
of
the
north. The
If
opposite of north,
anywhere
right?
looking towards this outer circle of ice, anywhere towards the circle is south to us. That's how the flat Earth circumnavigation works, right?
No, 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 no. South is the opposite of north for you, and north is toward from where between you and the North Pole is north, right? That's north on your map.
Yep.
And then south on your map is 180 degrees the opposite direction. Right?
So this person right here looking towards the play button would be north, right? North.
Yeah, if you look towards the play button, that would be north. And so
So
180
then south
degrees
is
from
every
there.
direction over here. Oh, hold on.
South is
So
only
south
one
would
direction.
be
Not every direction. South is only one direction.
right, but the perspective from each person is looking south. If they look south this way,
The directions don't have perspective. They're absolute. On your
Okay.
map, your own map there, south is 180 degrees opposite of north. So
I'm sure
right there on this one, so the person in Africa is looking, I'll go back to the previous one. That was a good one from the top. There you go. So the person in Australia, or sorry, in Africa is looking about south. I'll give you that. But the person over there in Australia is looking northwest, according to your map. And the person in Brazil is looking what direction? Northeast. But in reality, they all look south to see the Southern Cross.
so on the flat Earth circular map, west is a circle, east is a circle, right? Not a straight direction.
Yeah, but when
As
you're
is-
at a point, when you're at a single
Mhm.
point, you could
Right.
point, you could stick your arm out in the direction that is west, right? And if you faced west, you'd be facing west, even though on the flat Earth map, west is a circle. But if you stood at one point, you'd look west and you'd be looking west, and that's it. You wouldn't be looking in a curve, you'd be looking straight, right?
Okay.
If you turned another 90 degrees and you looked due south, you're looking south. You're looking away from the North Pole towards the nearest point of Antarctica to you, approximately, right?
Mhm.
So on that map, the guy in Brazil, so put your cursor over the guy in Brazil and then move your cursor in the direction that is south.
Right. So let's see.
That's Africa, not Brazil.
Right. This way. All right. So whoop.
There
South
you go.
is also this way and this way. No,
No, it can't be two ways at the same time. It's only one way.
it's away from the center. But you know, we can concede this point and call it a win for you guys if you like, just to move on to other stuff. Because this is a tough one, and you know, it's my only example, and it is a stumbling block. So I mean, this is the one weird scenario where everything would line up, and technically it could be possible in our mind. That's my only argument to that.
For two reasons, what Michael said, obviously, and definitely that's wrong for the sun.
Right.
Okay, go back to where you had the time and date.
Mhm.
Okay, no, the time and date. Yeah, not this one, but the actual one with the Mercator map.
This one.
No, the actual Mercator map. The real one. The real one. Yeah.
Whoop. Man. Love me, BitChute. Love it. Thanks.
That's okay.
Huh.
The real one, anyway.
You mean this
The one that you get from time and date. Yeah.
Huh.
You showed us before.
I had it open. Was it on this one?
You had it open before. The one from time and date, the one that you used to show us that where you had the Southern Cross. Yeah.
All right, 1 second. Whoop, there we go.
Well, that was me.
We all hate Professor Dave, as you can tell.
Yeah, there. Oh, you almost had it. You had it and then you left it. Back. You almost had it. There we go.
Yeah.
Yeah. You see this map that you're looking at over here?
Mm-hmm.
Okay. This is based. Why are there these humps like this?
to
What does that
represent.
mean? What does it mean that this hump over here, that hump, straight up above Southeast Asia? So you got Indonesia, you got Sumatra over there,
Right.
running here. You got Vietnam's directly above
Right.
that, Russia, right?
Hmm.
And you can see that's in daylight.
Right.
Okay, so the people over here in Southeast Asia are in the dark. The Russians are in the northern Russians are in daylight, right?
Right.
This over here, that only happens because the Earth is a sphere. This can't happen on a flat Earth either.
Well, it's actually this right here, but stretched out on a flat map, right? So if we curve it and we take it and we spread it out the way this map is, perpendicular, horizontal, then the sun and the path yin yang that are formed, the moon and the sun, would actually be a parabola almost,
No,
up and down, a cosine.
You can't turn this into flat. This comes off a globe. This only works on a globe.
Right. So if we take this map right here.
Have you any idea how this Mercator map is produced, by the way?
This one I don't know.
Let me show you.
Go ahead.
You stop sharing for a minute, please. Sorry.
Yes, sir. Let's see. Do I have to stop or can you just overwrite me? Let's see.
I think I have a photo.
Got it.
Okay. All right, that's good. So let me see if I can. I probably should have asked, gone and looked for it first, but let's see if I can work out why. Because it's actually quite interesting in the way it is. I thought I had a picture of it. Maybe I don't. That's down here. Okay. Oh yeah. Oh, yeah. Here we go. Here we go. Just okay. I can see it. So I'm going to share. I'm going to open it first. Here we go. Okay. All right. So now I'll share this. So, if you don't know, you learned something today. At least.
I usually do when I come on the show. I got to tell you.
Okay. Thanks. Yeah, that's good. Well, we learn too, we just
new dumb things first think is what I gathered, but that's okay. I just listen to the comments.
you said it. Okay. Okay. I was trying to be more kind than that.
Work thick skin.
I don't know. Well, you're quite an approachable fellow. So, all right. So have a look at this, and this is kind of how it is. Imagine you took this. So you took the Earth as a sphere and poked it in the middle of this cylinder, and then at every point that's on the Earth, you transpose that point to the cylinder. Okay, so you can see over here it's going to be distorted over here around the north, and it's going to be distorted around here at the south. So around here towards the equator, it's reasonably accurate. I mean, it's still got some distortion here, but over here it's going to be quite distorted. But that's basically how they make it. And then you can see now that now you then just cut it down wherever you like. So you can see this one's cut here just before the Bering Strait. Okay, so there's it's over here where they've sliced it, where they've cut the cylinder just before the Bering Strait. Okay, and then opened it up. And there you have the Mercator projection.
So it's definitely warped as a map.
But definitely comes off a globe, doesn't it? And that's why. And that's on a flat Earth. There's no reason for this to be wide like this, right? That's just not working.
Well, every map is distorted, right?
Why would that's a good. Why would a flat Earth map be distorted?
Let's see, the Gleason's map, I think, is our best non-distorted equidistant map. That's the one I would go with. And that's not technically distorted.
We've already said that's irrational, but yeah.
Well, is it distorted though? Is it?
Well, it is because we already
incorrectly sizing a continent, or
like what you showed me. I am an Australian, and I have been around my country, and it's definitely not long and thin like that, like a sausage dog.
So does the Gleason map distort continents then proportionally? Is that
Why does it? It's flat, isn't it? That's the actual representation of the flat Earth, isn't it?
yeah? I think that's the best we have.
Why should it be distorted? I can understand this ball, trying to flatten this ball, definitely will get distorted. But why should a flat Earth showing a flat map be distorted?
Do we know it's distorted? Is that a known fault of the Gleason's map?
The Gleason map shouldn't have any
distorts
faults.
continent sizes. Okay.
Why should it have any faults?
The only thing it does then is distance. That's what makes it equal.
No, but,
the distance measurement on the Gleason. So that a correct statement?
Okay, so Shane, I can't count how many times I've flown from Perth to Melbourne.
Mm-hmm.
So many times I've flown from Perth to Melbourne. Now, I know how long it takes to get from Perth to Melbourne. We know the distance that it is from Perth to Melbourne. That's the reality of it. It doesn't get longer. It's the pilot doesn't say, you know what, passengers, I'm just going to pretend that, that the plane's going a bit faster so we can cover this a bit quicker.
Right, but that Mercator projection.
How does that make sense?
The Mercator projection is still a warped spatial map. When you wouldn't plan flight routes that way, would you? Is that what they do?
Why not?
So this is the map that we used to map the 26 flight paths that prove flat Earth, right? That we said we used the wrong projection on the globe portion. No.
The people who use this map know that it comes from this sphere, and they know what the scale is.
Right. So the continents are not out of proportion, but the distance is out of whack because it's even with the heliocentric, it's a globe flattened out, right? So
okay, all right. Just because the continents are out of whack, certainly the ones up here, just because these are out of whack, that's fixed by a scale. Okay, that's the point. They don't look at that and say, oh, I'm just going to get a ruler and I know that from here to here is going to be the same as from here to here. That's fixed by a scale. Well, I should be going this way because it is right that way. That's fixed by a scale.
Right.
People, navigators who use this map understand this.
So where would the radius of the Earth apply on this map to equal it out? What is the 6,371 meters? From which point to which point does that equal? Well,
the diameter will be from the meridian, which is over here where the UK is. Okay, so right across here, there's the UK right over there, right? So it's Greenwich, right? That's one side of it. Where's the other side? The 180. Well, we can just count them, and we can work out where 180 is. It's somewhere around. That's the international date line, isn't it? Yeah, around there, close to Hawaii. Yeah, so that would be where it is, and that would represent the diameter of it. So if we're just looking at this, let's say Hawaii was about here somewhere. I think that little spot over here. So international date line would actually be right there on the edge of this. Although it's wonky because everybody wants to have their date, but the actual line, the actual split, if you like, if you split the globe, it would be there and there at England. Okay.
Where's the North Pole on that map?
Well, it's up here past Greenland,
right,
right there.
But I agree.
And because it's a globe, because it's like this, it would be like this Antarctica. This Antarctica is not like this. Okay.
No, we know.
I mean, it's sort of stretched out. Okay. Stretched out. So because if you thought that, then that would go right down here, like this in this huge circle. Antarctica is almost a circle, so that would go huge like that, which would be totally wrong. Okay. So So that's because this map is so distorted, of course, because it comes from a globe. Because Antarctica is just
I
around.
agree.
It's just over here at the 60. Okay, it doesn't go around the edge of a flat Earth. It's
Right.
just over there at the bottom of where the South Pole is.
Cylindrical proportion, missing the top and the bottom sphere portion. I guess what you call it, the area, right? So,
well, this is just to show you where it is. I mean, if you actually went and got a Mercator projection, it would have everything. This would actually be larger than that because they'd want to show you all the different bases that are available in like for instance Scott Base and Davis are opposite each other, and yet you'd be able to see them on a Mercator projection. Okay. Now, look, while we're just talking about this, I'll just unshare this one because I want to show you another one. Okay. I'll show you a different one. Okay. I think you'll enjoy this one. Okay. Actually, I like this one over here. Let me see. This looks good. It's kind of along the lines of what we're talking about now. Oh, well, why did that do that? Okay, it'll give us an idea. It'll give you an idea. It's not exactly the one that I wanted to show you, but never mind. I'll just share this, okay? Here we go. Okay, just having a look at this. You can see this all right, yeah?
Yep.
I might be able to set like that. Okay, I think that's as much as I can take it. So these are longitude and latitude, right?
Yep.
Okay. Do you know when that was actually invented?
For nautical sea miles, way back when.
190 BC.
Right. Okay.
Yeah, 109. That's 190 years before Jesus Christ was born. I mean, if you accept that.
Right.
Okay. Before Jesus Christ was born,
Okay.
before when people say he was, right? So that calendar, 190 years before then, this was created.
But I mean, these work perfectly well on the Gleason's map, right? That's what we were just saying. The arc degree is exactly 60 nautical miles, isn't it? All the way around.
No. The reason I said that is because to tell you how long it is that people have been thinking that have been knowing that the Earth is a sphere.
Sure.
That's the reason that I told you. But there's something else I wanted to point out with this. Okay. You see, you can see quite rationally that if we have a look at the equator, it's 0, yeah, going across Brazil there. Okay.
Mm-hmm.
You pick any two spots along the equator, you can see the distance, right?
Yep.
Pick any two spots along a latitude. Say this latitude at 30 degrees south is the same as this latitude at 30 degrees north, give or take a few kilometers, all right?
Same as in how?
Well, it's the same latitude.
Okay. Well.
But this along the equator is much, much bigger than longer in distance. If you pick two places between two longitudes, is much, much more than two places than either south, 30 degrees south, or 60 degrees south, than 30 degrees north or 60 degrees north.
Right.
That doesn't comport with your flat Earth thing, does it?
Sure, it does. A little small circle and a big circle.
No, but this distance over here, on yours, the equator, the distances south of the equator are much, much bigger than the distances north of than the equator, aren't they?
Right.
Let's
I see what you're saying. Mm-hmm.
Yeah. let's unshare this and you'll see what I mean. Just keep this in your mind, okay?
Yep.
All right. Okay. All right. Keep that in your mind. I've got a flat Earth folder.
I don't have a globe folder.
Yeah. Gotta find a flat Earth. Well, I had one before, didn't I? I think I'll just use the one I had before. A lovely flat Earth folder, a flat Earth map.
You put a clown face on
I got a few. No.
it.
Be childish, no, of course.
Well,
I've got one with a big red cross on it. It says no.
big X, right? Yeah.
The big X on it. Yeah, I do. I do have one of those. Okay. Okay. I quite like this one. It's very colorful. All right. So let me share this with you.
Mm-hmm.
Okay. Okay. I guess you like this, don't you?
I do.
So, you know, like I said before, Australia's, you know, so totally out of whack. Okay. Now, this is an interesting part about this. Okay. This distance over here is pretty right. Okay.
Okay.
This way. All right. From the north to the south. That's pretty right, that distance.
All right.
But this distance here, east and west, is totally screwed up. And that's why Australia is out. But let me go on. So because these distances are right, then roughly from Sydney back there to here, I don't know, 10,000 miles about there.
No way. Yeah, from that North Pole to the outer ring should be about the radius of the Earth, 6 million meters ish.
Yeah, but okay. So all right. So let's have a look. So all right. So
Radius.
The radius goes to the equator, doesn't it? Yeah.
North Pole to the outer ice wall would be the equator of this spherical flat map.
Why don't we?
Right?
Why don't we just? I'll just grab my iPad and I'm going to say Sydney to the North Pole. Okay.
Mm-hmm.
All right. So just give me. Okay. All right. Okay, just bear with me. The distance. Sydney.
4,279 ish miles.
North Pole.
Right.
Okay. The distance from Sydney to the North Pole is 7,572 miles. Yeah. Okay. 7,572 miles. That's because you're thinking about the equator. Okay. That's why, right? All right. That's what you're thinking about. You're forgetting that the equator is sort of around here going through Brazil. Okay.
Okay.
All right. It's much further than that. Okay. It's almost around the other side. So from Sydney, from there to the North Pole, right, is 7,500 and what did I say it was? 7,572 miles. Okay. Now you remember how to find the circumference of a circle?
I believe so.
Okay, so that's the radius. That's 2 pi r, isn't it? 2 times pi times the radius. Well, that would be about 50,000. So this distance around here, where Sydney is, will be about 52,000 around here where Sydney is. Okay. Just a rough estimate. The sun takes 24 hours to get around once. That means it must be going overhead. more than 2,000 miles per hour. Shane, I don't know about Boston or even Minnesota, but I promise you this, I don't see the sun going whoosh as it goes 2,000 miles. My city, I'll tell you, I live in Melbourne, roughly 110 kilometers across. If the sun was going to go around at 2,000 kilometers an hour, how long would it take for it to cross 110 kilometers?
Not 24 hours.
It would be minutes, wouldn't it?
Right.
So yes, I would see it going whoosh like that,
Right.
wouldn't I?
Yeah.
You're a rational person. You agreed that you were a rational person. How is that rational?
So let's see. What's 8,000 miles, 8,500 miles in meters? Isn't that like, what, 100?
1.6 times. So it's 1.6 multiplied by 1.6. So you got the 8 and then 0.6 of that. So half of that again.
Right.
Half of that again.
So you were going to say the distance from Australia to which point before I pointed out the North Pole?
The North
Right,
Pole.
You were going somewhere else with it, I
the
think.
North Pole to Australia, to Sydney was 7,572
Miles. Right.
Yeah, because I mean it's got the distance from there to
Right.
you got to think about the whole lot, you know. What's the whole?
I'm just trying to work from meters and miles to my head real quick because I knew it in meters.
Like 25,000 miles around, isn't it? Yeah, circumference. So obviously this is a significant distance.
Let's see.
25,000 miles.
I think if we do it in meters, I had it. Let's see. Yeah.
I did it in miles because
12 million meters ish.
because Americans like miles.
We do. But I was using McTune's meters measurement and I didn't convert it. What I did was I took his radius measurement and applied it from the North Pole to the outside of the Gleason's map on the isosceles triangle it gives you in the map. That's what I was basing it on.
Well, I'm kind of old, so I remember those. Okay. So that's not rational, is it?
I forgot what the original question was, to be honest with you. we went into it so
I was
deep.
saying that the sun going over my city in a matter of minutes is not
At
rational.
light speed. Of course not. That's absurd.
It is absurd. Well, it gets worse. The sun in the summertime is 14 hours over my city.
Right?
Yeah. 14 hours. What does that mean about the rest of the world?
Right? Wait a second.
What's 24 take away 14, Shane? What's 24 take away 14?
Wait a second. Is that from the whole continent of Australia, or just your city? Are you saying it passes from the eastern to the west to the eastern side of Australia in 14 hours? How does that leave the rest of the world without sunshine for the most of the day?
It's tilted. It's a globe and it's tilted.
How do we know it takes 14 hours? I mean, the daylight is more than 12 hours in the summer.
You can look at time and date.com and have a look. I mean, it's an estimate, 14 hours. It might be 13 or 15 or something like that, but it's certainly in that region. Like, you get up at 6 o'clock in the morning, the sun's there, and then it goes till 9.
Right.
Well, that's at least 13. So it's not rational, is it?
Those criteria are irrational.
At the very least, Shane, there's a problem there, isn't there?
Definitely.
Yeah.
There's definitely some assumed variables that are incorrect.
Yeah. So remember we were speaking about the distances at the equator. So the equator, see around here, that's Kenya. So Nairobi is about 5 degrees off the equator. something like that. Actually, there's a hotel over here, which I've been to, right on the equator in Kenya. And then the equator goes all the way through to Brazil, as you showed me yourself. So there it is. It goes all the way around. And it goes here just near Singapore. Eh? Right? Singapore is very close to the equator. All right. That's where the equator is. Well, if you have a look at the distance between two of these longitudes, okay, you can see, for instance, over here, that's over here, I'd say that's the island of Java. Okay. Java or Sumatra, maybe Sumatra. It's hard to see. No, Sumatra goes this way. Yeah. So Java, the island of Java. So the island of Java, which is the sort of the main island where of Indonesia, that going across there, you can see between this latitude, this longitude, and this longitude of that island is a lot smaller than back over here where Tasmania is, you know? Right? That doesn't work on flat on a flat Earth, on the globe. The reality is it doesn't work, because the reality is that that's not true. The reality is that the distance over here in Sumatra, okay, across here is bigger than the distance over here where Tasmania is.
Between Tasmania and what?
Well, over here in this distance, between these two longitudes over here.
Oh.
Let's say,
I see.
Let's go back for years.
I see what you're saying. I got you.
Okay, Sydney to Adelaide is much, much shorter distance than across the entire length of Sumatra, of Java.
Right.
So that's not rational, is it?
Sure it is. The longitude lines on the flat Earth look just like that, and they get wider outside.
We can't accept this one, but I'm happy for you to sketch a flat Earth map where the distances at the equator are longer than the distances further south and further north. It seems that they work further north because you see they're shorter over here.
Right.
Okay, so it works further, but the trouble is in the southern hemisphere, it goes all screwed up. The distances are just wrong. That's why Australia is so wrong.
Okay.
So you got your problem with the sun, trying to get around, you know, that whole thing, this whole area in 24 hours. That's impossible. All right, because it's got 14 hours, spends 14 hours over here, while it's supposedly going at 2,000 miles per hour. That's just wrong.
Okay, that is wrong. Agreed.
All right, now I know flat earthers, you know, and I don't mean that in any derogatory sense. Okay.
Well said. I appreciate it though.
All right. Okay. So it is funny though, I have to say. All right. So from here to Sydney, we're going to go all the way around here. Remember, we're almost going half a way around back to here to South America. Okay. So Santiago is, Santiago is Chile. So it's on this coast over here. Okay. So all the way around here, almost half of the globe, not quite half of the globe, but, you know, half would be about here somewhere, right? So half would be about there. So about 10 degrees worth of half. That distance over here, remember it's 50, remember what we said, it's more than 50,000 miles. So over here would be, well, if I said it was like 48, I'd be really kind. So you tell me how an aeroplane gets around 48,000 kilometers in 12 hours.
Are we talking about the airplane or the sun?
No, the aeroplane.
Does an airplane travel in jet, what do you call it?
I saw the jet streams. That's
Jet stream, that's what it is. Right?
I saw
around the outer edge.
How fast are jet streams?
Oh, I have no idea of the measurement there. I just know it goes a couple hundred miles faster than the plane would go if it goes with it, right? So it cuts down on the.
You think 200 miles is enough?
Well, I know it's faster. I know it goes faster than it would by itself, right?
Look, this plane that's going over here, going around in 12 hours. That goes in 12 hours. That has to be going 2,000 miles an hour. Well, it's half of that. So yeah, more than 1,000 miles per hour. You know a passenger jet that can go more than 1,000 miles per hour?
So we're saying the sun goes faster than planes around.
Not me who's saying it. You are.
Right.
You're
Okay.
saying you said the sun goes 2,000 miles per hour. That's your claim, not mine.
Okay. Sure.
You can see that's irrational. And
Yep.
we're both rational people. We agreed.
Yeah, that makes no sense.
It doesn't, does it? Do I need a lot more?
For me?
Hmm.
You want to help me out understand on my map over here? Do the same example?
You try and challenge me now. I think
Well, I want you to educate me because now I'm kind of, well, that doesn't make sense, but what I'm looking at
Right.
makes a little bit more sense, but I still can't quite understand the speed of a jet with the jet stream added to a flight time to see if it actually makes a reasonable circuit around the flat Earth, right? So
well,
let's see if we can do it.
Qantas flights 27 and 28. 27 goes from Sydney to Santiago, and 28 goes back.
Oh, these are the globe proving flights that I forgot to look into from last time, I think.
You seriously need to, because there's no way known. No airplane goes more than 1,000 miles per hour in order to achieve that. Okay, that distance.
Agreed.
That's nearly 20. That's nearly 25,000 miles.
Yeah, that's absurd.
Okay, it's not happening. There's no jet goes that fast.
Nope.
Actually, it's 2,000 miles. What am I talking about? That's
Either
ridiculous.
way, it doesn't go that fast.
It's ridiculous. It's however you look at it, it's ridiculous, isn't it?
Agreed.
Yeah. Okay. All right. So it's irrational, in other words. And we're both rational people, remember.
Those parameters are definitely irrational.
Yeah, I agree with that. Yeah, exactly. Okay, so I think you mentioned something about a dome over this thing.
A barrier, sure, yeah. Nope.
Is the sun on the inside of it or the outside of it? How far do you think this dome is? Because I recall you saying something like, I don't know. What did you say? It was a few thousand miles.
73 miles up.
72.
380,000 feet, something like that, yeah.
So the dome is only 72,000 miles up.
73 miles up, yeah.
Okay,
380,000 feet.
Sure. Okay. Yeah, that's cool.
Cool story, bro, right? Yeah.
But it's a dome then, is it?
A barrier.
Have you worked out how high it is from Melbourne?
I know from, let's see. Nope, I know from the North Pole. I know from, the 80 degrees south parallel. I know 13,000 feet from the outer edge at 80 degrees south.
Well, our little cousins over here, there's at least one smart one over there. He's like a little wolfie. I'm not really sure about the rest of them, but there's at least one smart one over here in New Zealand. Right near, not far from here, from the edge over there, where the dome comes down. Pilots would have to be really careful, wouldn't they? They don't bump into the dome at that level, at that, because the dome goes up like that, doesn't it?
Yeah, let's see. I had one good for this.
So that's irrational, isn't it?
No. Here, let's see. Whoops. Close it.
You don't think that? Just
there we go.
Yeah.
There we go.
Do you want to share it, dear?
Yeah. Well, I wanted to get my measurement because I forgot the. There we go. Okay. Damn. Okay, I'm ready. And
You know, while you're doing that,
I got it. Oh,
you ready, are you?
yep.
Should you want me to stop sharing?
Please.
Sure. It's all yours.
Okay. So let's see. These are the measurements that I'm working with.
Mhm.
Right. So 80. Yeah, 80 degrees south, 13,000 feet up, 30 to 85,000 from the middle, roughly 73 miles up. So you're saying that a plane would hit the dome if it was on the outer edge flying around? They have to try extra hard because of the
No, not from
open
your,
ceiling.
from your particular thing. Just looking at that, how high did you say it was? Just 100 and
So the middle, the highest, 385,000 feet, roughly 73.5 miles.
so the sun is on the outside of it.
Sun's right here. So on the inside of the dome, right?
Well,
Inside here, moving around.
hang on a second. You told me the sun was 110 miles.
Yeah, but I made that up. Right? I didn't know what math we were going to prove at the start of that example, and you told me to make up a number. So,
So the sun's what, 70, you said?
well, below 73 miles, right? So I'm saying the barrier is 73 and it's below that.
All right. So, and the moon too, yeah?
Yes. Yep.
Does the moon give us cold light?
We think so.
Then why doesn't the sun heat up the moon?
We think the sun and the moon are their energy system of the earth, the anode and cathode. So they work in tandem, right? The sun and the moon gets
Okay. So
further away from.
anode and cathode, are we talking about, say, like a galvanic cell, you know, plus and minus, all right?
We're saying one, works off the other. The charge from the moon gets.
How does it do that exactly?
I have no idea. We don't know how it stays up. We don't know what it's made of.
I know how galvanic cell works backwards. Okay, so I want to know, you know that you need to complete the circuit, right? For anything to happen.
But just for an example, that's what we think. That's why we think it's going around. So we think.
Yeah, okay, but you do have to understand how electricity moves, don't you? Would you like me to explain it?
But we don't know how the electricity of the sun and moon work exactly. We're using it as an example in a simplification, right?
But we do know how electricity works.
We do.
Yeah, so I can explain it to you, and then you can see if it's rational or not.
Electromagnetism?
No, I'll explain it.
Well, let's just stick to the ceiling.
Let's
I'm good because we don't really know how that works. We don't know that it's exactly like the battery system that we
do
have.
know how it works, and if I explain it to you, you'll see if you can then make up your mind if it's rational or not.
Was this going to prove how the moon couldn't possibly give off cold light? Is that how this started?
Well, you can work on that. Let me just explain it to you. Okay, because you used the word anode and cathode. Those are important words in physics. Okay.
Mm-hmm.
You have to stop sharing. I thought I could unshare you.
Yeah, anode and cathode relate to anions and cations.
Yes, that's right.
Hey.
All right. You need to stop sharing.
Didn't I? Oh. Didn't I stop? Oh, nope. No. Looks like I'm done. Am I still sharing?
Yeah, you are. I can.
Oh, you want to just boot me?
No, he's right now.
Oh, I got it. It's hidden.
Okay.
Be a very quick lesson. So I got a jar. And then we got another one. Everybody's seen this, I'm sure. Okay. And here we got an electrode. Make a red one here. In there. Okay. I'll use one of these. Ooh, where is it? There. Nice. Electrode in there. And Electrode in there. And we'll have a solution of maybe copper sulfate in one of them. So
You need a
let's say,
fluorine in one of them.
yeah,
Let's
so
have fluorine in.
yeah, fluorine in one. Yeah, that's the end of the glass. If we did that.
Oh,
so let's say we had copper sulfate, and this was inside it. Okay, and over here we have zinc, for instance. Okay, so what happens basically is, so over here the zinc is clear, so I'll just leave it like that. So basically what happens is we have, this is called, if we connect these together with a wire, right, and we'll put an ammeter right in the middle of it, so we can measure the current, and we go across here. We can actually put a voltmeter. Okay, all right, so we're going to measure the volts, and then we have to complete the circuit. You see, nothing's going to happen like this. Okay, nothing's going to happen until we put until we do put another one in here to complete the circuit. That goes in there. Okay.
So now the current, there you go, right?
Right. It's not going to happen without completing the circuit. Nothing's going to happen between the anode and the cathode. Okay.
We don't know that the sun and the moon aren't connected, though.
So say this is the cathode, then this will be the anode. Right. Nothing's going to happen between them. So if this was the sun and the moon, how do they get connected together?
Well, if the sun was an energizer battery and the moon was the other side, then this copper wire would need to be there. But we don't think that's exactly how it works. And I couldn't explain to you exactly how the sun and the moon work with the energy. That was pure, speculation on my part.
Well,
right? So
let's just say, can I just say that without actually working out how that is, that speculation is kind of irrational, isn't it?
Sure, I'll give you that one.
Yeah,
that speculation is irrational.
Okay, so from here on in, whether you take on board what we've discussed today, you can drop this one out of your lexicon, right?
Or I can try really hard to figure out how it works.
Or do that, because I'd really love to see how you move the electricity. Do you know why electrons move, right? So let's say, for instance, we got a cross section of a wire. Well, it won't be that shape. Let's get one of these.
Yeah.
So we've got a cross section of a wire, and like this. Okay. Like this. Electrons don't actually go in the middle of it. They don't actually move through the middle of the wire. They move, they're on the outside of the wire. And that's what makes metals shiny. The fact that the electrons hang around the outside, not the inside. That's why metals are shiny, for that reason. And it's these electrons that, because they're on the outside, they can move. So let's say, for instance, in your house, you've got lighting wire that you can put the lights on with, and then you've got the power wire, which you run your heater or your stove or something like that. So if that was the power wire, your lighting wire would look like this. This can take a lot more power than this. Okay, and that's because there's a lot more surface area around here than this. If you tried to put this to carry your stove, this would heat up to the point where it might even cause a fire in your house. So these electrons are on the outside. So while you're trying to figure out that, please add that to what you need to have done. Okay. Right. Because
I'm going to get surgery or something.
Well, I was just thinking about how, because for us to get the 240 volts where we are, I know it's the 120 where you are. Okay. And I think you're 60 hertz, aren't you? So the 240 volts at where we are, and we're 50 hertz, which makes sense. Okay. and that's 240 volts. That's peak to peak, because it'll be less than that RMS. Okay, just divide it by √2. Okay, and if we're where we are, imagine how big this is 2.5 millimeters for this to happen, to carry that 240 volts at 10 amps, 2.5 millimeters. Can you work out, please, for the sun lighting up the moon, how big your cable must be? And why can't we see it?
Well, we started this with the sun produces a cold light, right? We didn't do anything to prove or disprove that.
Well,
We had me guess that it was an anode and cathode, and now we're on this discussion, right?
I just want
can't.
I just want you to lose that from your lexicon.
Well, I can't refute this, and I don't have a better example, and I can't explain how it would work otherwise. So, fair enough.
I didn't think you could. Yeah. So,
All right. Can I before you
go
ahead, you want to stop your share?
I'm going to have to call it to say you might have to call up the when did we start, Michael? I can't remember now.
It was about an hour ago.
Okay.
What?
All right. We can keep going for a bit longer if you like.
All
right. So there's a couple questions that I think might be pertinent while you're still here, Phil, because Phil needs to leave earlier than Shane does.
Yeah.
So Mark Sermon is asking to Shane, what are your remaining reservations now that Phil has kind of gone over a few things and given you answers and things that you can't explain. If you can't explain it, then it's rational to say, well, that's probably not something that I could stick with.
So the same thing that would convince me last time, right? The 73-mile rocket, uninterrupted footage straight up past that border where I think the dome is. That would definitely prove it from any source. Any rocket that goes higher than 74 miles uninterrupted would prove it to me.
Okay, so
I'd be back on your side.
All right, I can definitely show you that.
We can deal with that. That's easy to deal with.
Yeah, I mean, there's lots of them. All right. So I'll work on getting that here in a minute. Let's see here. We got Rob Parks says, great to see Professor Phil. Need to get him on my channel for a bit.
You can come on my channel too, Phil. That'll be fun for me if you like.
Just work at a time.
Sweet.
So all right, Rob Parks also. So Rob, do you know Phil? Do you know Rob Parks?
Yes, I do. Yeah, fine astrophysicist or astronomer.
Excellent. All right. So we got Beach 8 has been a member for 2 years. Says, hi again. Good to see you, Professor Phil. And we've got Obi-Wan is a new member at Newton. I'm trying to get the ones that are pertinent to you. Oh, here. The Plain Truth. Travis, who's a flat earther, if you know him, says, yes. I don't think he's here anymore, but he says, I triple dog dare Professor Phil Bell, and he misspelled your name intentionally, I think. A little naughty
I'll
there,
teach you.
Travis, come on. To produce a physical model with 2 celestial rotations and an equatorial buffer. I did, of course, ask him to send the link to the one that he created for Flat Earth, because he wouldn't expect that somebody else could do something that he could not do. That would be quite hypocritical. But yeah. I'm sure that physical model will be forthcoming. But anyway, Bill Bell, you've been triple dog dared to create a physical model
or
with
bipolar sphere
poles and an equatorial buffer.
As long as he's prepared to come here and criticize it.
I mean, and certainly he would bring his physical model.
He can bring his
of the flat Earth with 2 celestial rotations and an equatorial buffer.
I would have a lot of fun with that. I can promise you.
I don't even know what that is, to be honest.
I've been very kind Shane as I should, because he's a
Right.
gentleman. And the plain truth is a little bit less than that.
Yeah,
So,
and he's
I'm
gotten
actually
less gentlemanly over time.
surprised to find how much anger goes on in this debate on both sides, huh? What the hell?
it's
The most
unnecessary.
divisive thing I've ever seen. I don't understand.
I think so. It's unnecessary, actually.
Right?
All right, we've got Cretan Bull says Professor Bell is putting on a master class in logic. All right, let's
Thank
see.
you.
We
Yeah,
got
probably should have brushed up on trigonometry too, huh? Before I came on with you.
yeah. There's about high school level trig is about all you need for most of this.
Yeah.
Humphrey Pushcart for $6.66 says
with you.
Wolfgang Pauli heard Professor Bell and smiled. Understandable and brilliant. Well done.
I would have taken your class, Phil.
I'd
I
love
would.
to have you in a class. No problems.
How can we all enroll in your class? We all want to.
If anybody wants to learn something particular in physics, write that in the comments in Michael's and file, and then perhaps he can contact me and let me know what it is, and we can make a class. How's that?
You can help us prove flat Earth by answering all our questions, right?
We could try.
Fair enough.
Send me a DM. I'll be more certain to receive that. I can't read all of the comments.
We could try. We could try.
LB Things Stuff and More says, Professor Bell, what time is it in Australia? Love ya.
Okay, so it's 20 past 2.
Whoa.
In the afternoon.
20 past 2 in the afternoon. So LB is she's been around quite a while. 2 years, tell you what, 2 years ago, May, I was doing a live stream after all the things that happened in Minneapolis here. And the tree in our front yard fell down during the live stream. And LB, she was on the channel at the moment that the tree fell down, and I had to run outside, and because all we heard was a bang. We're like, is that gunshots? Was that an explosion? We're looking all over the place. I look in the front yard, the tree is down. It was like an 80-year-old tree. It was
That's a hell of an expensive thing, right? After that, jeez.
Yeah, I called up a
Tree
friend
removal is
that
crazy, yeah.
a friend that does tree stuff, and paid him cash, and all the tree is in the side yard still. We haven't burned all of it. There's
Just say firewood, right? Yeah.
Many years of firewood to come.
So, Michael, can I ask you a question?
Yes.
Why does the Great Seal of Minnesota say L'Étoile du Nord?
I just went over this with one of my kids. It's the Nord, right? It's Nord.
It's the Star of the North, yeah.
Yeah, it's the North Star.
Yeah.
Because we see the North Star from
where it
here.
comes from.
What's that?
I'm just curious because, I mean, on one side you've got an Indian on a horse who's a Native American on a horse who's, and on the other side you've got a farmer who's not even wearing shoes.
I suppose in the 1800s, maybe farmers didn't wear shoes.
Possibly.
But yeah, I was just going over that. So yeah, the North Star, we see that here, and your flag has the Southern Cross, which we don't see from here.
Yes, true. Very good.
Things that according to perspective, if the Earth were flat, you could see the North Star and I could see the Southern Cross.
Absolutely. That's a problem for you, Shane.
Perspective demands that we would see it.
Yeah, absolutely.
Some stars are tricky.
Even after you think the sun's disappeared, magically just disappeared, we still can see the stars.
The stars, which would have to be farther away than the sun, and not nearly as bright, and we still see them.
Yeah, exactly.
That's a curious thing to
a
non-rational thing to hold on to.
Totally
non-rational. Well, that's because we assume we see all of the stars at once everywhere, right? You only see a portion of the
exactly, which is a problem.
Array,
but the ones that you do see are definitely farther away than the sun for flat Earth,
all right?
Right?
Actually,
definitely farther away.
That's really interesting. They're actually the ones that some of the sun east and west of you. So if you look east and west of you, those stars are actually further apart, further away from you than the North Star. You can see them. Where is the sun then?
What do you mean, where's the sun? That always gets me.
You can see the
sun. Stars are farther away.
Mm-hmm.
For flat Earth, the stars are farther away and not nearly as bright as the sun. We can see the stars, but we cannot see the sun. That doesn't make sense. That's not rational.
So you can't see the stars from the opposite side of the dome, let's say, all the way on this side. If you're over this
Whatever
side,
stars you are seeing at night, the stars that are immediately above the horizon, according to flat Earth, they must be farther away than the sun.
Absolutely.
Right.
And yet, the sun, which is brighter than the stars, you cannot see. Why?
It's not rational, is it? Okay.
Well, it is. It's just tough to explain. Right. So even that Eric Dubé video that I'm not a fan of, you know, how the southern stars work on flat Earth from Eric Dubé that everyone hates.
The distance.
Right. But that model with the portion of the circular dome being visible from where you are is the furthest one you can see is maybe halfway through the top of the dome, not to the other side of the dome where you couldn't see where the darkness would be.
But if it's halfway through, why aren't the stars up there? You can see the stars immediately above the horizon. Those stars, where are they?
It's not rational, Shane. Let's face it.
It's a tough one.
I can draw a little picture here even to
southern stars are a tough one.
Illustrate. No, I'm Eastern stars.
You can't quite explain something that you don't understand 100%, right? And that's never something that I was able to articulate. The southern stars, the Southern Cross visible, like that example I pulled up was the perfect combination of circumstances that maybe you can let it see, right?
Here's flat Earth and here's the dome, right? Mm-hmm. So the sun is somewhere. Let's put it there. Right? There's the sun. Now let's put our observer over here where it's nighttime. Would that be nighttime for that person?
No.
Right? Because the sun is on the other side. But when that person looks immediately whatever direction, it doesn't matter, north, south, east, west, you see in all directions, you see stars. So if you look this direction, if the stars are on the dome, you're seeing these stars way over here, right?
Yep.
But you don't see the sun, which is much, much brighter. Why do you see the stars here, which are dim, but not the sun, which is much brighter?
Something's wrong with that example.
You bet.
I couldn't tell you exactly what. Hold on.
Well, what's wrong with it?
Let's see.
It's flat Earth is wrong. That's what's wrong with it.
Silly Glober. So, man. So let's see.
It's not rational.
I'll give you. I mean, you're not gonna.
No.
You're not.
I'm trying to understand it anyway, so I can better argue it next time, at least, right?
Well, all right. I mean, maybe you should just figure out that doesn't make sense. It's not rational. All right. Let me. All right. A few more here for while we have Phil. Cretan Bull for 5 Canadians says Shane isn't learning actual science that can explain things more gratifying than unsubstantiated flat Earth claims that can only be asserted.
Unsubstantiated claims were not satisfying at all. Absolutely correct.
Okay.
I'm sure you didn't like that answer, huh?
I love that answer. This is a good one. So Keith Miller for 20 Singaporean dollars says,
that's a lot of money.
Quote, "We don't understand electricity," says the man using a complex electronic system comprising billions of working parts, precisely controlling and orchestrating electricity in countless ways.
That's not what I said.
Well, did you not? Did you?
I said the sun and the moon don't work the way our battery systems work here, which is
Okay.
why I was hesitant to go into the explanation in the first place.
Okay.
But
So you don't know how the sun and moon work.
correct.
Okay. I mean, that kind of goes back to the previous one, the unsubstantiated claims one.
Right.
Okay. I think those are the ones that that are relevant to Phil. And it is an hour and 15 minutes from when we started.
Yeah, I'd like to listen. I've got about 15 minutes more to go. If
Okay.
you like, I'd like to listen to some questions that get passed on to Shane.
All right. Let me roll back there. Eddie Reese says, Shane, how fast would a sun 32 miles in diameter need to travel to circle the flat Earth in just 24 hours?
I don't know. Very slowly, slower than a plane. Right. We can sort of see it. You can track however the fast the sun goes across your skies, how fast it goes around the world in 24 hours, right? We're supposing
Around where I live, more than 2,000 miles per hour.
Yeah. And where I live, which I'm north of the Tropic of Cancer, so it never gets this far north, but it would have to be significantly less than 2,000 miles an hour. So it'd have to speed up from June 20th or 21st, from whatever speed it would have to go here, which should probably be in the 500 to 700 mile an hour range. I'm kind of roughly estimating that, which you would, if it was the right speed, you would hear sonic booms all the time, which we don't do, to over 2,000 miles an hour,
yeah,
where Phil lives, and you would definitely hear sonic booms then.
Oh, yeah. Totally.
We also don't know the sun is a solid object, right? We don't prove that either.
Well, people have bounced radar off of it, so there's that.
You know the interesting
And
thing.
the laser from the moon too. That's about as cool.
So Shane, the interesting thing is that while the sun is going 2,000 miles per hour over my city, it's going maybe 1,500 miles per hour over Singapore, and in northern Russia, it'll be going like about 800 miles per hour. So the sun somehow manages to go different speeds at different places at the same time.
It must be magic.
That's got to be irrational, right?
Well, we don't know if it's solid. If it's a projection, it would seem to be in a different spot for every person that observes it. So you wouldn't
going
see
at a
it.
different speed.
Speed would be again perspective, right?
But what's it projected from? What's it projected on? None
idea.
of this. This is all just kind of wild.
Just
conjecture.
saying stuff I don't know. Well, I'm just saying, if it's not a solid object, then the speed thing goes out the window. But the speed that we observe the sun at is still.
But it does output heat.
It does, and a little bit of electricity, right?
No, not electricity. And it
3.9 by 10 to the 26 joules per second.
Yeah, I saw that. I saw your video on that one, Phil. I watched that whole one, actually.
That's not electricity, by the way. That's energy.
Yes.
And it's photons, not electrons. Right? Photons are what? They're the electromagnetic, the boson for the electromagnetic force, right?
Yep. The return energy, if you like, after the electrons get reach their ground state.
Okay. We've got Brian Peck says, yes, the Gleason's map distorts continents, oceans, and even the radius of the equator. And that's an interesting one because the distance from the North Pole to the equator is easy. It's 60 nautical miles times the number of degrees, which is 90. That's that number is an absolute fundamental number in celestial navigation. It's been used for centuries. If that's wrong, then navigators would not get where they're going. So that distance is known. Yep. Also, the distance of the equator is known because people that live on the equator measure things and know the size of their ground, just like the people in Australia know the size of their ground.
Right.
So when you actually do the math, when you use the circumference formula, which is
2 pi r.
2 pi r. So you take the radius, which is 60 times 90 nautical miles, convert that to miles. The radius of the equator is not that quantity on the Gleason map.
Irrational.
And
you're a rational man.
It doesn't match
I was.
observation. So there's that problem. There's a lot of problems, and all these do work for the globe. So Brian Peck says that should have been circumference, not radius. Okay, so even the circumference of the equator is what he was talking about. It was the second super chat that came in.
So Shane, this is why people like Oakley will say we don't claim any map. That's because they know how irrational it is. But I'll tell you how irrational they are. They claim to be expert navigators. So they must have some map that they're working off. I've yet to see a navigator not have a map.
They claim to be expert navigators, but
they
never has
the flat Earth sextant, though.
Never has one of them actually done any celestial navigation and got a fix.
Well, from what I see, they can't even work out an elevation angle.
They don't know the geometry.
You never used the flat Earth sextant, though. You guys are missing the tool.
I haven't seen that one yet. It must be as fictional as the flat Earth, the accurate flat Earth map.
I think I have it. I think Oakley's
Of course. Obviously, maps. The maps are known because people fly between cities.
Yeah, ships go.
And ships go. So they must be using the correct map. And little secret,
they're hiding it.
You can get the very same map that they use. It just my son is training to be a pilot, and he has on his iPad. He bought an iPad just for flying. He has a subscription to the map service. I forgot which one he uses, but so he can map a flight between Santiago and Sydney on his iPad. So, all right. Eddie Reese says Professor Phil Bell is literally hitting Shane with the sword of 1,000 truths. It has zero effect.
I wouldn't say that.
Shane, let it have effect.
I don't not learn things. I took things away from every time we come here.
That's okay.
Let's see. Stringer News 1. He's not a fan, Shane. He says, never underestimate the power of dumb. While the brightest minds can move mountains, the dumbest ones can prevent those mountains from being moved.
Oh, my feelings, dude. You got me. Ouch.
Right. Obi-Wan says there's so much
You really just paid money to call me dumb? That one's easy, man. Come on.
Obi-Wan says there's so much reaching for every crazy, incredible magic theory for the Earth to be flat, yet the globe is easily explained and explains what we see so simply, yet you reject the simple.
Yeah.
I mean, there's a map. You can
well,
get
it's
it for
easy
free.
to believe, right? You can just believe. You have to do no work.
But Shane, it's not a belief that planes use, actual globe-based flight planning. It's not a belief. That's
Shane.
So we're saying that planes can't fly on a flat Earth. That's silly, right? Of course they can.
Planes,
Even if
planes could not map on a flat Earth.
Yes. That's.
I mean, they could if they had an accurate map, but there is no accurate map that anybody's ever provided.
I have a suggestion for you, Shane.
Sir.
All of you should get together and see if somebody can go undercover in one of these shipping companies and steal the actual map.
I love it. That's a great idea.
It'll be right next to the fake globe, probably. Sorry.
Mr. Monster says ocean currents debunk flat Earth, especially the Antarctic circumpolar current, which is the largest ocean
Yeah.
current, only possible through the Coriolis effect.
What a coincidence that
Like
was.
that one?
That's the air.
If we do the moon parts, it makes way more sense on a flat Earth. But
That doesn't actually make any sense, because if the Earth is stationary, like you probably say, right? Then what's the point? What's causing those movements?
I'm not going to speculate. But
Right.
those
So
are
if
the movements, and they
if the
look
Earth
pretty on the circle.
is moving and rotating, then we have an explanation for why that would happen.
An explanation for sure.
Yeah. All right. Alyssum says, missed most of this. So don't know if it's brought up, but why is there no flat Earth alternative to the Haversine on which international navigation relies? So in case if you don't know what Haversine is, the Haversine formula is a formula that is a three-dimensional trigonometric function that gets the distance between points on the surface of a sphere. And that's what flight planning software uses to determine the route between any 2 points. And that's incredibly important for all navigation, because you need to plan how much fuel to bring, whether you're on a ship or you're on an airplane. If you get that wrong, the results could be disastrous.
Yes, the plane actually did get that wrong, but the pilot was brilliant. Landed at Tenerife with no fuel at all.
And getting too much fuel is also bad news, because large planes like the commercial planes, 747s and stuff like that, they cannot land with too much fuel because they can't stop soon enough. They need a longer runway to stop if they have too much fuel, because they have too much kinetic energy.
More weight.
So what they do, and of course the chemtrailers play this video, they dump fuel. It's a waste of fuel. It costs extra money, and it's a pollutant, so nobody wants to do it. But they dump the fuel. They actually pump it out so that they can reduce the weight of the airplane before they get to their destination. So, and so like when they have to do an emergency landing that's unplanned, they have to dump fuel, which is really expensive.
Did I see you in a chemtrail fluff video somewhere? Was that you or someone that looked a lot like you? Did you do a music video making fun of chemtrails?
No, I have not. I've only addressed chemtrails once.
Michael is a expert. Doof 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 doof.
A what? Conspiracy theorist debunker.
Were you beatboxing, Phil?
Yes.
I swear this was you. I swear to God. Can I just show you real quick? It was blowing my mind. I'm like, is this Mike?
All right.
Let's see.
Activity in Sector 5. That's North Indiana, Sector 5. Anybody see that?
That's not me.
Okay. I'm sorry. It looked it looked like something you might do. That's why I wasn't sure.
That's great. I would definitely do something.
It gets good. It gets good, right? It's a nice little song. He's got that super.
Yeah. All right.
Okay.
You want to stop your share? I can science that says Phil may be a worse rapper than you.
I'm sure that's the case.
I am a terrible rapper. So. Yeah. All right. Timbo Turtle says, Shane, if Professor Phil measured the angle of the sun from Melbourne now, and I measured it from Canberra or similar longitude, the height would be different.
Is that a question?
No, it wasn't. So let's see. So Melbourne versus Canberra. I don't know the latitudes and longitudes.
Canberra is much higher than Melbourne.
Okay.
Melbourne's at sea level. Canberra would be like 500-600 meters.
Oh, elevation?
Yeah, elevation. Yeah.
Okay. So Hunter has a correction for you, Phil. One correction for Professor Bell. The sun in Russia is a special gaseous operation.
There you go.
I'm not smart enough to get that joke, I guess.
I think it's an inside joke. Special gaseous operation in Russia.
Nope.
Can you explain for us, Phil?
Talking about the sun's the Russian energy situation, I presume. But anyway, what he is pointing out is that he's being facetious and saying that sun is somehow different. It's not the same for us here in Australia as it is for the
I was
Russians.
going to say it's probably Putin's
I
fault
see.
then, right?
Yeah.
Everything is Putin's fault. Caucasian Sensation is wondering, what is a Flurf sphere? Sphere itself.
That's actually pretty good. Props, man. I like that one.
All right. So here's a challenge for you, Obi-Wan, from Obi-Wan to you, Shane. He says, so Shane is loving the attention, and if he gives up this nonsense, he will no longer get this attention. So he
I actually hate attention. I'm antisocial. You know what I mean? To be honest with you, I do this to try and learn and to, get better arguments and rationales, which hasn't
Shane,
actually failed.
We haven't even touched the surface of this.
I'm happy to have you back on anytime, man. I want to have you, we'll do some talk, some Zoom chats.
Yeah,
we'll get some stuff going.
We really only looked at 2 or 3 things.
I need you to debunk a whole bunch more things. I'm happy to go through it, man. I really appreciate it, though.
Well, I'm glad to come on too. Hopefully the audience enjoyed it. That's the main thing.
When we don't yell, I don't think they do as much, to be honest.
All right. Stringer News 1 gave the background to that. He says Putin made it illegal to say the war in Ukraine is a war. They call the war a special military operation.
Right. Yes.
The sun would then be a special gaseous operation.
Yeah, gaseous threw me still.
Got it. Drew Gifford says, for £5, says, great to witness 3 of the nicest gents from both sides. Thank you for a pleasant, informative, and entertaining evening. Much love from the UK.
I misspoke then. I guess they do like some nice rational conversations.
There you go. And Alyssum says, MC, hope your kid takes you for plenty of flights. I hope he does too. So somebody asked is he doing it for career or for hobby. He's hoping to do it for a career. He's playing with the idea of going to Alaska to fly some. I guess you can do a lot of flights there in a short amount of time, so you can get some hours in.
He could join the Air Force.
He could. And he talked about it. It's one of the things that he's gone over. But he has a girl that he's kind of serious about, so that would mess with it.
The hell of a date, huh? Want to go for a flight? No, I got my own plane. Here, come on around.
Yeah. So. All right. So I have that's the super chats for now. I have a video where I thought I sent it to you, but maybe not. I will grab it.
I do have to go.
All right.
Prepare for a lecture. So that's been a lot of fun. I thought it would be. And Shane, you've been a gentleman. I was going to add to it, but I will add that if you come back and say that yes, it is totally irrational and you're Glover, I will add scholar to that. You will.
I would like you to debunk many more things before I get there, Phil.
You're quite right in my estimation as a flat earther. You'd be skyrocketing if you came back and said that yes, this flat Earth is nonsense. Is the nonsense that it is.
I'd like to be back in the rational world too. It'd be fun.
All right. Well, come back next time, and I'm sure Michael will indulge us, and we can go through,
Thank you.
serious things. Okay.
Thank you, sir. Appreciate it, Phil.
Michael, thank you very much for having me.
Yep. Glad to have you.
I do hope your audience enjoyed the evening and the morning. The people who are here.
Excellent.
Okay. Goodbye.
All right.
Bye, Phil.
Okay. So.
Got to rearrange quick, and then I will.
Where?
There we go. That's good for now. I have, let's see, a whole Evernote group here. So uncut from ground to space more than, what did you say, 74 miles?
Yep. 74. So
Have
I
you-
don't think anything's gone higher than the 2014 Go Fast rocket. Unless something
Oh,
has.
there's a lot.
Well,
Did you look?
20.
The question
I
is,
looked
did
on
you-
Wikipedia for the highest, I think it was highest rocket altitude reached under, I think 360 was the next closest one. 380 was the Go Fast, 380,000 feet.
You mean amateur rockets that just went straight up and then straight down? Came down?
And rockets that went past 73 miles straight up. Yeah, in any which way,
Right, well,
uninterrupted.
all right, I gotta.
I did see one you
Share
showed
this
earlier to someone else uninterrupted, but I don't know if it went as high as we needed to go. And I don't know if it was measured or tracked at that height. Let's see. But if it was, man, I better get my globe shirts instead of my flat F shirts out.
All right, this is from 2014, a video from 2014, but the actual source is earlier than that. This is STS-134, so one of the final shuttle missions. SRB left forward, so this solid rocket booster left forward. Now, this particular video shows several views of the rocket in sequence. So I'm going to double the playback speed. So, and this, I think these don't have much lens distortion in them either. So, and I don't know the exact height of this where they disconnect the solid rocket boosters. Maybe some other people can look that up quick. But the shuttle certainly goes higher than 74 miles. You can see so far uncut.
So far, I'm with you. About to be a Glober.
There you go. So that's apogee there. And it does look like it has a little lens distortion. It's not like a GoPro. Those are terrible. So there you go. So there's that one in the same video.
Oh,
In the same video. Let's see. So here it is. The solid rocket booster left aft. So this is looking up, which isn't quite as interesting.
you think it would be though? We always want one to look straight up,
Yeah,
or I do.
it's not, because I mean, once you go through the clouds, which it looks like it's done there, now all you see is just a gradual darkening of the sky. So it's kind of boring, but it's there.
So do we see stars as we get up there too, or no?
I don't know how if this goes high enough to see stars. We'll see in a second, though.
I mean, one of the hot air balloons you had showed stars, which I thought was weird.
Yep, and it's difficult to get a video
I think
of
I have them
stars
both.
when there's something bright in the foreground. I mean, you can do this at night. You can go
Right.
take video of a tree, and if you can expose for the tree, then you might not be able to get stars. Certainly, if there's something bright nearby, you won't get it. So now this is going horizontal there. There you go. The shuttle kept going. So no stars in that particular one.
Inclination altitude 122 nautical miles. Is that this one? Nope, that's 2008. different launcher, the same thing?
So, and then there's a video of it falling back to Earth.
STS 124, nope, 134.
There's the parachutes. All right, there's another one looking down. Move ahead here. This is the third. Here's another one looking up. So we've got two looking up, two looking down. Here it's returning to Earth. Well, there you can see there's the other solid rocket booster.
Mm-hmm.
But I don't know what that top right is. See that 140? Don't know what that is.
Right. I don't know what's 150 at that altitude anyway. Oh.
It might just be the time offset.
Hmm.
But you can see here this lens is distorting.
Try to find the altitude this thing went up, even from NASA and Wikipedia. What did the records say? Did anyone find it in chat?
Well, this would be, yeah, at what height does the booster separate? Because it's going to be pretty similar. So there's one. Let's see. I just have notes here. I'm not reviewing them first. So this is from ESA, that's from Europe. So Sentinel 1A. So this is from 2014. This liftoffs, various stages in rocket ascent. The satellite being released from the upper stage to start its life in orbit around Earth. So that's orbit. Low orbit is 200 miles. I think is pretty low. It's going to need to be higher than that.
The people that go on the low orbit rise go way below that. When they go to space and they go just kind of low orbit flight, right? They go lower than 73 miles for sure.
Who?
The people like the when they took some rich person up not too long ago.
Oh yeah.
Suborbital flight or whatever.
That's not an orbital flight. So this is going to orbit. So in order to go to orbit, it has to be higher than, the minimum orbital height. So there you go. Remember, this is playing at, I think, double speed. Yeah. So here's the fairing release. So there's another one. Let's see. All right, this case is about 146,000 feet is when separation happens.
So 388,000 feet is what we're looking for, right? That's
Keith Milner says 238,000 feet is SRB
385. It's my threshold. I don't even think they've recorded something cresting that direct up.
Atlas 5 from 2020. An Atlas 5 rocket from 2020. Go. All the ice. You know why there's ice on there, right?
Is it because it's cold?
Well, yeah, but why is it cold?
Because, what's the layer? The atmospheric layer is the what's the layer? Heliosphere or something that goes cold then hot?
No, it's cold. It's cold on the ground. All that condensation is from low elevation there. That's because they fill it with liquid oxygen and liquid helium or hydrogen sometimes, but probably liquid oxygen.
But isn't like even the basic model of the what's it called? The internal atmosphere gets colder and then there's a layer of hot on top. I think I saw somewhere.
But the ice happened at low elevation.
Okay. Gotcha.
Because that's where the air is and that's where the moisture is. When you go up, you don't have air and you don't have moisture. You can see here the edge of how far out the rocket flame is. It's not a flame, right? But you can see how wide it's getting. It's getting wider as it goes up because there's less and less air. So when it comes out the bell, it expands to the side more because there isn't as much air. As you go higher, it gets even wider, and it goes even off screen to get to the edge of it. So, where's the dome?
This has nothing's gone 390,000 feet up. They didn't even claim it on here. This could all still be well under that threshold. Yeah, I know it's a finicky thing, but if I see it, I will doubt myself.
All right. So here is the second second stage. Looked like Balanced Truths had agreed to debate Tommy Gronwald on Tommy's channel, and he's gone a little quiet. So
The flirt debating community is large, huh?
all right, let's see. I'm going to jump ahead a little bit. So it's right now, it's coasting. There, it's deploying the satellite. This isn't a satellite. That's going to Mars. So,
I think it's in Canada the other direction.
it's what?
It's in what do you call it? Where do they film the Mars stuff? Newfoundland. Where they had a base that looked a lot like where they sent the Mars footage from, but it was in an island in Canada with the NASA base on it.
Did you not do the research on that?
No, I did, but it can be refuted, right? So
no. Here's how you do that. It's easy.
Oh yeah.
You find where NASA posted that picture. Right? The one they're like, well, this is Arizona, or this is Greenland, or this is whatever. Find that picture that they claim on NASA's website. Right? You never will. Because they actually didn't take it from NASA's website. I don't know if it's flat earthers that are intentionally lying, or if it's a globe earther that's making a meme to feed to the flat earthers to make them look bad. Because it looks really bad if you're like, this is what NASA says, but it's not actually a NASA picture.
Right.
That's pretty embarrassing.
Yeah, Greenland is what they said, right? Yeah.
All right. This says inside a rocket from takeoff to orbit, external cameras in HD.
Wait. I need the stats for these. Even from NASA themselves. How hard did they claim it goes?
Well, I will tell you what. I'll send you these. I have them all in Evernote, so I'll just copy paste the whole thing to you.
Sweet.
You can look them up.
Because I think it still holds the record. Is that Go Fast rocket for something?
No.
Highest, I think. No.
No.
I think it was on Wikipedia.
I mean, the highest for something. Yes, in a particular narrow niche of what it was doing. All right, so look how big the plume is there. And it's getting bigger as it goes higher. Jump ahead a little more here. There. It turned off. There you go. So yeah, you can look up these. Let's see if there's any more here. Here's one more. One more. I'll send you the whole list though. You can look up how high each of them was. This is
One fly is killing me. How are you still in my house? How are you not dead yet?
This is the
Jesus.
GOES, the GOES S rocket cam. Jumping ahead. There you go. Bearings cut off.
Let's do this. Atlas 5.
People are. I don't have you on screen. They're wondering who I'm talking to. This is Shane St. Pierre. Finish this.
Just a lowly flurf. So that one went. Let's see. Come on.
So the Atlas V is a rocket that has gone at many different times with different payloads. So
Yeah, I see that.
you
I'm
want
looking at it now.
the GOES-S rocket. So here is, I think it's
58.3 miles, 52.4 with Starliner. Close.
oh that's in general. Is that the
This
first
is
phase?
from all of them. Yeah, so it lists all the phases. That was the highest.
Okay. Well, but we saw the second.
But yeah, the second phase was whatever the highest number I gave was whatever the highest phase was. So this is how you,
No,
yeah, 50.
But this is going into orbit. This is not orbiting at 50 miles high. Right? Orbits have to be higher than that.
Let's see, boosters would drop at that. Second booster, first stage, second stage.
So, all right. Let me. I gotta fix this. The scene. So what is still? You've looked at that. Is there anything else? If you look at those and say, all right, well, they went higher than whatever the
73 miles, 74 miles, right? Yep. If I don't even think they claimed to, though. I think that they claimed the separation happened well before that threshold, even in the NASA documents, because there's no reason for it to go higher than that before it separates, right?
Yeah.
Either way.
Well, it depends. Different rockets have different ways that they do things.
Right? If it's going to Mars, say, it would have to go all the way out, not to a different location.
No, when it's going to Mars, step one is to go into orbit.
Mm-hmm.
Then once it's in orbit, then it will launch again and then send itself off into its trajectory.
So here we go. This is what I was looking for. Flight altitude record. All right, so it's got balloons, fixed wing, rockets, and piston-driven propeller airplane, whatever that is. 367, 382, nothing above 390. But this is what I was looking at before making wild claims.
KN says the U.S. Argus 3 nuclear test in the atmosphere went up 466 miles.
Cool story.
But I have no idea if they have video available from it from 1958. Probably they didn't have a GoPro.
There's a whole bunch of other issues for that first, like nukes.
All right, I have that for you. I'll send them to you after. Let's see here. I think that's what we have. Phil covered things well.
He's a nice guy, huh? Can't believe you guys haven't done that before. Was that your first welcoming time? Is that why you wanted to be quiet for him? You give him a little bit of a.
Oh, it was between you and him. So
right, but on your show.
Yeah, I don't have to talk the whole time. It was I was just hosting, so.
Sweet. That was fun. It was nice either way.
Let's see. We got Czech Starfish Prime nuclear tests. They took place at 250 miles. Well, people, if you can find, and
Rockets.
here's what would be ideal, would be as much as possible a video that has as none or as few interruptions as possible, going up to a high elevation.
And any sort of citation that cites the height from any source, right? They're going to keep it open that way.
And of course, and I Can Science That has a great point. NASA doesn't do videos for flat earthers. They don't care. Their budget isn't dependent on flat earthers believing them.
What do
Their
they spend
budget-
$63 million a day on?
Their budget is about accomplishing the things that they've been set to accomplish.
What have they accomplished?
Well, they keep putting people on the ISS.
Uh-huh.
They launched the space shuttle
Uh-huh.
well over 100 times. They have
Yep.
many satellites that they manage.
So they're furthering science all over then?
Yeah,
Or they're putting on a show?
it's not just putting on a show, because if you built something yourself, right? If you were the guy that was one of the main designers of something, right? You would know it well. And then you're going to interact with that thing that you made for the next 5 years or 10 years. You know it well. And if you made a mistake, because we all make mistakes, and so engineers make mistakes in code. If they write software, they make mistakes in circuits, they make mistakes mechanically. They know about it. Because it causes problems. And software is one of the big things. Because software is an undocumented, a bug in software is undocumented. So you can't fake that to a programmer, especially because I didn't write the documentation for it. There's a problem with it. So if a lot of flat earthers say that people are compartmentalized and they don't know that they're being faked. But well, if I'm the engineer, you're the engineer, you're interacting with the thing that you designed. Somebody has to be on the other side of that magic curtain sending you the data, because the thing that you designed, where is it now? Did it get destroyed? Did it land? Did it get launched into the Bermuda Triangle, as many flat earthers say? Well, for the next 10 years, you are interacting with it. If it doesn't exist, then what are you interacting with? There has to be something on the other side of that magic curtain. And if it's a person or a group of people that are faking the data to you, how are they going to fake an undocumented bug?
I don't think that they're faking it like that at all. I think they're doing real work, real math, with real experiments, with real variables, with real measurable results, just not the ones that, and we're not claiming NASA. I mean, we're claiming NASA does fake things, but not everything is fake. And, they really sometimes launch a rocket. They really sometimes do some things.
But
people have components.
But if you are interacting with a rocket that's in orbit, or a satellite that's in orbit, a weather satellite that's monitoring things.
Satelloon, sure.
No. You designed a satellite. You shipped that satellite to be installed on the top of a rocket. And then that rocket went up. So that thing that you designed is either in orbit or somewhere else. Where did it go? Some people say it just splashed down in the Bermuda Triangle. But now you are interacting with that satellite that you designed. What are you actually interacting with?
Data it sends back, maybe pieces that are recovered. I don't know.
But it's
what?
But where is it? It's in where? It's somewhere. Because if it went to the Bermuda Triangle, or if it did anything other than go to space, where is it? And how is it that you're interacting with it? If it's not where you think it is, how is the person that designed it fooled by it?
So if a person designs a satellite and they instead put it on a balloon and float it up, it does its job, achieves its function, returns its results. How would they know any different? If it's orbiting around the globe, or if it's up on a balloon in a high altitude orbit looking down?
Huge difference. The location of something that's on a balloon is random. It's just moved around by the
Well,
wind.
if it's like gauging the pressure at a higher altitude, right? If that was the
Yeah.
purpose of the satellite, that could be achieved in both circumstances without anyone being the wiser and without any magic required, right?
Would it not be useful to know the location of the pressure? Of course, a satellite isn't doing a whole lot of measuring of pressure.
You just,
Because
if I was
the
designed,
pressure at that high elevation is
Right.
low enough that nobody cares about measuring the pressure. So let's say it's taking photographs.
okay,
Right? Who is you are the engineer that designed it, and you are telling it to take a photograph. But there's a bug in your code that you didn't document, so nobody could have faked the bug. And something isn't working right, and you're like, oh crap, what's happening? Oh, and you go to your source code. So this is what I do, right? I write software,
right.
and I pour through the source code. I'm like, oh no, that variable I did something wrong with. All right, let me write the fix to it,
Right, not
Right.
return expected results,
and
whatever.
let me send up the software update to the satellite. So now that undocumented bug that caused problems has been fixed, and it's now actually on. How does that happen?
I mean,
These things do happen.
That's not a crazy blanket statement to make. I mean, what if the trajectory got bunked and you send the code to fix it and it's still going back up to its path to go up to sit where it sits below 73 miles and hovers over the earth, say?
But it's
Whatever.
But its location is important. So PhD Tony has a good point here. For the GRACE satellites, our results rely on intersatellite distance. We use the positions of the two satellites and the distance between them. So these two satellites, they use laser range finding to see how far apart they are from each other, and their location is critically important.
Yep.
So how would that be faked?
I don't understand why they're not faking it, right? It's going up there, it's doing something like this balloon right here. If they put it up there to connect to the balloon next to it to show the same thing, I mean, the laser could target it and turn it.
How are two balloons that are randomly being moved around by the wind and their positions being tracked very, very precisely? How is that going to work? Because their positions aren't going to match, because an orbit is a very particular
Would require
motion.
orbital speed, right? A certain amount of speed to maintain orbit.
Absolutely. And it's very predictable. It's going to be here, and then in 40 minutes it's going to be here, and in an hour and a half it's going to be here. But it's unpredictable if it's just a balloon, right? You don't know where it's going to be.
Satellites never proved anything to me. Right? We all just assume they're up there and doing everything. So I never
kind of
questioned.
bailed here. You kind of bailed here.
Well, I mean, like, it's not an argument that, like, I didn't even I never said they were faking satellites, right? Or they were faking everything in NASA. I said that they were doing things that maybe were
But they would have to, because they move at ridiculous speeds for being in the air. Multiple kilometers per second for being in the air.
Let's see.
But that's not how
NASA's,
fast balloons move. Balloons don't move that fast.
Correct.
So it's just, remember, you need to explain everything for flat Earth. And every time you're like, I don't have that, I don't have that, I don't have that, I don't have. All of these things are like, oh crap, I have this large pile of things that the flat Earth doesn't explain. And all of them are explained for the globe.
I mean, there's nothing that we need to explain via satellites in space for returning error code bugs mid-flight. Like, I don't know, everything's the way it is currently on both models would be fine. If it's satelloons or satellites are orbiting, they're returning data using the traffic tower, sending signals. But
a rational person would have to say, okay, hold on a second. Yes, that engineer is interacting with the product that they designed.
Right,
for 10
but
years.
rational people don't trust the government or NASA.
It has nothing to do with that at all. It's the guy that's just he's an engineer.
It's got everything to do with it for us, though. You know that, right?
All right, so then you have to say, and this isn't rational, all of those people that work at NASA are all in on it. Not
at all. That's crazy, right?
I agree. It's not rational.
But I mean, That's not an argument that's going to prove anything to me. That's not. I'd rather just concede that one to you and put it on my pile of junk I have to go through to present my flat Earth
All
package that I tote around with me.
All right.
The rocket one though, I really want to see.
All right. I think we're good. You have Phil's email, and if you want to have him come on your show, you want to come back here sometime, that's all good.
I'll send him an email. I appreciate the hookup and the opportunity again, Mike. It's been good. It's always good fun, and I appreciate learning.
Yeah. All right. Well, everybody, thank you very much. I'm actually out next week. I have one debate that has not been aired on my channel from quite a while ago, but I don't know if it exists. I don't know if I even have a copy of it. So I don't know it. I may not have a video next week.
Zoom cloud, right?
I will be camping, and the network is going to be slow there. So anyway, people, I will have a couple videos that are on the Conspiracy Tunes channel, which is linked in the description. Be looking for those. We'll see y'all later. Thanks a lot, everybody.
Thank you, guys.